It's Friday evening, and Marco's team merges a change to the billing module with no security review because nobody even asked for one. Nothing breaks that night, which is the worst version, because nothing gets noticed either. On Monday, Nadia, who owns the merge gate, gets one sentence from her director: make sure this can never happen again. Freeze on that sentence because the Claude Certified Architect exam is built out of moments exactly like this one. Here is Nadia's Monday, written the way the exam will write it. A payments team must never be able to merge a change that touches the billing module without a security review. Which approach satisfies this? 4 options, and every one of them sounds sensible. Add the requirement to the project's instruction file so the reviewer always checks it. Document the rule in the team's README and link it in the pull request template. Add a hook that blocks the merge whenever billing files change with no security review attached. Or tell the review agent, right in its prompt, that billing changes always need a security sign-off. 3 of those 4 are the same wrong answer, wearing different clothes, and the people who pass kill all 3 in about 4 seconds. By the end of this episode, you will see exactly what they see. That question parks in the corner, because we are coming back to it. Once you're holding the 2 tools, this episode is about first, the promise, because this is episode 1 of a full course on the Claude Certified Architect Foundations exam. The guarantee is specific. The exam guide lists 5 scored domains with 30 task statements under them, and this course owns everyone. Every episode tells you which domain it belongs to, and roughly how many of the 60 questions that domain is worth. But the 2 tools matter more than any guarantee, and tool 1 is a claim about the whole exam. Every question on it is one of 4 design questions, and once you name the one you are inside, 4 plausible options collapse to 2. The 4 aren't a study trick. They are the decisions you already make when you design any system. So let's walk them. So here they are, one at a time, each with the weight it carries on the exam. Question 1. Where does the work run? One loop doing the whole job, or a coordinator handing pieces to subagents, or a whole team, or a headless run with no human present at all? Whenever an exam item describes work that's outgrown its current shape, it's asking you this one. It's also the biggest domain on the exam, roughly 16 of the 60 questions you'll sit. Question 2. What can it touch? Which tools it holds, which outside systems it reaches, what its configuration allows, and what its permissions forbid. Marco's Friday merge was a what can it touch failure, because nothing in the path of that merge was able to say no. This one spans 2 domains, tool design on one side and configuration on the other, and together they are the largest block on the exam. Call it 23 or so of your 60 questions, which is more weight than most people give it. Question 3. How is intent carried? You know what you want, and the question is whether it arrives intact on the far side. Intent travels in the shape of the prompt, or in a schema, or in a check that runs before anything downstream trusts the result. That's a fifth of the exam, about 12 questions, and almost none of it is about clever wording. Question 4. What survives? What the system still knows an hour in, what happens when it's interrupted, and what it does when it genuinely doesn't know. It's the smallest domain, around 9 questions, and the one candidates most often leave until it's too late. From here on, every worked question in the course gets stamped with which of the 4 it's asking. But naming the question only sorts the options, and sorting isn't killing, so the second tool is the one that finishes. You can name Nadia's question now, but a name doesn't strike options. So here is the tool that does the actual killing. Go back to the sentence her director said, because one word in it carries all the weight: never. Never is an absolute, and an absolute is a promise about every future case, including the ones nobody has thought of yet. So take every option anyone ever offers you and sort it into one of 2 piles. On the left, guidance. A line in an instruction file, a paragraph in a README, a sentence in a prompt, a convention the team shook hands on. On the right, guarantees. A hook that blocks the action, a permission rule that denies it, a schema the output has to satisfy a human who signs. The difference isn't how strongly the words are written, it's whether anything actually stops when the words get ignored. Guidance is read by something that's trying to be helpful, and a busy, half distracted helper can walk straight past a written rule. A guarantee does not care what anyone meant, it sits in the path, and the merge simply doesn't happen until it's satisfied. Marco's team didn't defeat a rule on Friday, there was nothing in the path to defeat. Now say the rule the way you'll use it on exam day. When the stem says must, or never, or always, or cannot, every option that offers guidance is a distractor. Advice can't promise never. Only a mechanism can. Watch it work on the cold open because the instruction file, the README, and the prompt are three costumes on one answer. All three are advice, and advice can't promise never, so all three die together for one reason instead of three. The hook is the only mechanism on the page, and mechanisms are the only pile an absolute can be satisfied from. Both tools are in hand, so now look at the thing you'll swing them at because the exam structure is published in advance. Here is that structure as one picture because the weights should change how you study. 5 scored domains in the guide's own order, and agentic architecture and orchestration is the largest single one. Then tool design, then configuring and running Claude code, then prompt engineering and structured output, and last, context and reliability. Under the 5 domains, the guide lists 30 task statements, each with its own knowledge and skills bullets. Exam items are written against those statements, so the exam isn't a vibe, it's a list, and a list can be worked through. So the coverage map in the description is that exact list with an episode number written against every line. If a statement ever has no episode next to it, the course is incomplete, and you should hold me to that. The list says what gets tested, and the guide even tells you how, which is the next surprise. Here is the surprise. The 60 questions don't arrive as 60 strangers. The guide publishes the 6 scenarios the exam is built on, and on exam day 4 of the 6 are presented, picked at random. So you are really working through 4 situations you could have read weeks earlier. And they are real systems, a support agent with tools and a resolution target, a code base with clashing conventions, a review pipeline like Nadia's. Read all 6 before you sit because walking in already knowing the situation is most of the time pressure gone. One gap though, the guides published sample questions, generous as they are, only cover 4 of the 6 scenarios. 2 scenarios ship with no samples at all, so most candidates have never seen an item shaped like either of them. This course works both anyway, and one practical door check is all that's left before we run the full method. The door check is about who can currently sit this exam, said plainly once and then dropped. Registration currently runs through Anthropic's partner network, which means a company email on a recognized partner domain. A personal address gets rejected at sign up, and joining at the entry tier is free for an organization. So if your employer isn't in the network yet, that's the conversation to have before you plan a sitting date. You'll also notice I never say the fee, the time limit, the pass mark or the attempt count here or in any episode because they've all moved before. They leave in the description and the cheat sheet where they can be fixed the day they change. So now let's go kill those options. Here is Nadia's question back at full size, and this time you're armed. Tool 1. Which of the 4 is it asking? The stem is about what the system is allowed to do to the billing module, so it's a what can it touch question. That already pays because any option that rearranges who does the work is off the point. Tool 2. Find the absolute. The stem says must never be able to, and advice can't promise never. So every guidance option on the page is already dead. The instruction file is guidance. The readme is guidance. The sentence in the prompt is guidance too. It's just wearing firmer words. 3 options. 1 reason gone together, and that's the 4 seconds I promised you. The hook is the only mechanism on the page, so the hook is the answer. And Nadia can finally say never and mean it. And notice what you never needed, because no flag and no product detail ever came up. You needed the kind of question and the rule that an absolute takes a mechanism, and that's the shape of most of this exam. Look at what Nadia carries out of that Monday. Her never again finally has a shape, and it's a mechanism in the path. 2 lines to walk into every episode with: name which of the 4 questions you are inside, then find the absolute in the stem and let it kill the advice. Advice can't promise never. Only a mechanism can. Next time the building starts, where every one of these systems starts with a single loop in a terminal on the exam's biggest domain. The reviewer already posted its comment on this pull request and it's still running. Same file, same finding, second comment, and now it's opening the diff again from the top. Nothing here is broken, the tools all worked, and the review it wrote was correct. It just doesn't know that it's finished. Whoever built this told it to stop when its own reply said the review was complete. So it's waiting for a sentence, and a sentence is not a signal. Freeze it right there, because that exact mistake is what this exam is built to test. So here is the stem, exam style. What should end this loop? That stem lives in domain 1, Agentic architecture and orchestration, the largest domain on the exam. Roughly 16 of the 60 questions you'll sit come from it, which makes it the one to be strongest on. Inside it, ours is task statement 1.1, designing and implementing agentic loops for autonomous task execution. By the end, you will know exactly what a loop stops on and when one loop is the right shape for a job. It's also the first build episode, so from here we are building one system, a pull request reviewer inside one engineering org. The architect question parked in the corner, all episode is the first of the 4. Where does the work run? Here is where the system starts, and it really is this small. One prompt in a terminal that says review this pull request, and one engineer watching the output land. For that job, that shape is correct, and to see why, you watch what happens between pressing return and the comment appearing. The exam guide calls this the agentic loop lifecycle, and it names the steps. So let's use its words. You send the model a request. The model replies, and the reply carries a field called stop reason. If stop reason says tool use, the model is asking you to run something for it. So you run it. You take what the tool produced and send it back. That's one full iteration. Then it goes around again. Request, stop reason, run the tool, return the result. And when stop reason says end turn instead, the model has finished and the loop exits. On our reviewer, those turns have names and they're worth memorizing. Read the diff, decide, comment, stop. Read the diff is a tool call, decide is a turn where the model calls nothing and just things. Comment is a tool call that writes to the thread, and stop is end turn. 4 steps, 1 exit. So the next question is, what separates this loop from an ordinary script? The guide answers that in exactly 1 sentence. So let's read it together. Tool results are appended to the conversation history, so the model can reason about the next action. Read that slowly, because it's the load-bearing sentence of the whole domain. Every iteration the transcript gets longer, and the model sees all of it again on the next turn. So the diff it read on turn 1 is still in front of it when it writes the comment 3 turns later. That's the story. The principle is the transcript is the loop's memory, and nothing outside it exists to the loop. Nobody's said yet who picks the next tool each time around, and that fork is one the exam tests directly. Now the fork, who decides what the loop does next? The guide splits loop, steering into model-driven decision making and pre-configured decision trees. Model-driven means the model looks at everything in the transcript and picks the next tool itself. Pre-configured means you decided the order in advance and your code just walks it. A fixed sequence is easy to audit and it can't handle the case you didn't see coming. A loop can, and it'll sometimes take a route you wouldn't have picked. So the question is never which one is better, it's whether the work has an order you can know in advance. Reviewing a diff doesn't You can't know before you open it whether this one needs a migration check or a test check. Refunding a customer does. Verify first, then pay, and that order comes from the business, not from the content. So the reviewer keeps the loop steered from outside by exactly one thing, that stop reason field. Tool use and end turn are only the two values you meet on a good day. So here is the field in full. Tool use means the model wants a tool run, you run it, return the result, and the loop continues. End turn means the model finished naturally, and it's the only value on the list, that means the work is done. Max tokens means the reply hit the output limit and got cut off partway through. Stop sequence means a stop string you configured was hit, so it stopped where you told it to. Refusal means the model declined the request. Pause turn means a server-side tool loop hit its iteration limit, so the turn is paused, not finished. And model context window exceeded means the conversation outgrew the room it has to fit in. Now read that list as an architect. One value continues the loop, one value ends it, and everything else is news. A loop that treats every reply that isn't a tool call as finished will ship a truncated review as a finished one. So why do loops still spin with all of this handed to them? Now for the heart of the episode, the difference between a loop that terminates and a loop that spins. A loop terminates when its exit condition is a fact the protocol handed it. It spins when its exit is something it has to interpret. Run the cold open back with that rule in your head. That loop stopped on review complete, so its exit lived inside a sentence. The guide is unusually direct about this. It names 3 termination anti-patterns by hand, so learn all 3. First, don't parse natural language signals to decide the loop is over. That's the cold open exactly. A loop waiting for a phrase inside a sentence the model happened to write. Second, don't use an arbitrary iteration cap as your primary stopping mechanism. A cap is a budget, and a budget is a good idea, so keep one. But a cap that fires is a loop that didn't finish, and calling that done approves a half-reviewed pull request. Third, don't check whether the reply contains assistant text and treat that as completion. A model can write a paragraph of careful reasoning and still be about to call a tool, so text never meant done. Waiting for a phrase reads the exit out of the content, checking for text does the same, and a cap just stops reading at a number. Those aren't 3 mistakes, they're one mistake seen from 3 angles. All 3 go digging through the model's words for an answer, the reply already carried in a field stated as a fact. So say the rule the way you'll use it on exam day. A loop exits on a fact the protocol handed it, never on an interpretation. The loop now stops properly, which leaves the bigger call whether one loop was even the right shape to build. The loop is built and it stops on a fact. One decision left whether one loop was the right amount of architecture. Nadia runs the merge gate here, and when the reviewer switched on, she asked one thing: will it hold? For one pull request at a time, with an engineer reading the output, the answer is yes, and building more would be wrong. One loop is enough when the job fits in one context, has no order you can know in advance, and produces one result a person reads. Add pressure to any one of those 3 and the shape has to change, and the exam knows which change goes with which pressure. Too much to hold at once, and you split the work. That's subagents. An order that must never be broken, and you stop trusting a loop to respect it. That's enforcement. Nobody in the room to read the output, so it runs unattended. That's a headless run. Today the reviewer needs none of them, and recognizing that is a scored skill. So let's prove it holds on a question built from the exact bug we opened with. The stem. The merge gate must never receive a review that stopped halfway through the files it was given. Today the loop continues while the reply contains text and exits on a completion phrase the team agreed on. Option A. Raise the iteration cap so the loop has room to reach its completion phrase. Option B. Instruct the model in the system prompt to always end its final reply with that exact phrase. Option C. drive the loop from stop reason, continue on tool use, exit on end turn, and treat every other value as an unfinished run. Option D, keep the phrase check and add a second check that the last tool call made was the comment tool. Name the question first. The stem is about how a run terminates. So this is where does the work run. Then find the absolute must never receive a review that stopped halfway. Option B is advice to the model, and advice can't promise never, so B dies on that word alone. Option A makes the budget bigger, and a budget was never a stopping mechanism, so a bigger one isn't a better one. Option D is the same mistake in a smarter code. Two content checks are still content, and content needs interpreting. Option C is the answer. Its exit is a fact the model handed over, not a sentence somebody has to interpret. And the last clause matters. Handling every other value is what keeps a truncated review out of Nadia's gate. Look at where the system stands tonight. One loop, one pull request, driven by stop reason, every other value handled as news. Read the diff, decide, comment, stop, and now you can say what each of those four is in protocol terms. 2 lines to walk into the exam with. A loop exists on a fact, never on an interpretation. And one loop is enough while the job fits one context, has no knowable order, and in one result a person reads. Next time a pull request lands with 40 files in it, and this exact loop does what it was built to do, one file at a time. The tools will work, the verdict will read clean, and somewhere down that stack you'll watch its attention quietly run out. The reviewer is working through a pull request with 40 files in it, one file at a time, exactly the way it was built to. At file 6, it reads a database migration that drops a column. At file 31, it reads code that still writes to that column. That's the bug. By then, the migration sits 25 files back, faded in its attention, so it never connects the two. It posts a clean verdict, Nadia emerges, and the right path breaks in production that night. Freeze it right there, because this moment, one reader thinning out over 40 files is what the exam asks about. The question is simple to say. What structure reviews all 40 files at full depth without attention fading at the end? That question comes from the biggest domain on the exam, Agentic architecture and orchestration, roughly 16 of the 60 questions you'll set. It owns 2 task statements in full, the coordinator and subagent pattern, and how a subagent is invoked and handed context, plus half of a third, deciding which tools each agent is allowed to hold. By the end, you'll know when one loop should become a team and exactly what has to travel in the handover. The architect question parked in the corner all episode is the first of the 4. Where does the work run? Start with why the loop failed, because the reason picks the fix. The reviewer didn't lack information. Every file was right there in front of it. What ran out was attention, because the more it read, the less firmly it held what it had already read. The guide calls that attention dilution, and its answer is to split one big read into smaller ones that each stay sharp. The structure the exam wants you to reach for is called hub and spoke, one coordinator in the middle, specialist around it. Notice what the drawing doesn't have. There is no line from one specialist to another. The coordinator does 4 jobs. It breaks the work up, hands out the pieces, collects what comes back, and decides what it all means. Routing every message through the middle sounds bureaucratic, but the middle is the only place you can watch the whole system from. If 2 specialists talk directly, that conversation would happen off the record, with no single place for a failure to get caught. One more thing about the coordinator, it's allowed to skip people. It reads each request and invokes only who's needed, so a one-line typo fix never wakes the migration specialist. And an option that always runs the full pipeline is usually your distractor. So the reviewer grows 3 specialists. One reads security, one reads migrations, one reads API contracts, and nothing else. On paper, that team is the fix, but nothing runs until the coordinator can actually launch a specialist, so wiring comes next. Launching a subagent is just a tool call, and that tool has to be on the coordinator's own allowed list, or nothing spawns at all. The guide calls that tool task, and right here is the naming trap that catches careful people. Current releases call the same tool agent, but task never fully left. It still appears in the startup tool list and in a denied permission record. So both strings are live at once, and anything you build to watch subagent activity has to match both. On the exam, rate the option in front of you, and if the stem writes task, then task is the tool it means. Each specialist is a definition you write once, answering 3 questions. When should I be used? What are my instructions? Which tools do I hold? A definition can also pin a specialist to a cheaper model or cap the turns it gets. So Nadia wires all of that up and reruns the 40 file pull request, and the migration specialist comes back vague again. Here is what just cost Nadia her evening, and it cost real candidates marks. A subagent inherits nothing from the conversation that spawned it. Sit with what nothing includes because it's more than it sounds. It doesn't see the coordinator's conversation, and it doesn't see the reasoning the coordinator did a minute before the spawn. It doesn't even see what its own previous run found. Its context window starts fresh, and exactly one thing crosses from parent to child, the prompt string inside that tool call. That's the whole channel, one string. Now replay the vague specialist with that rule in your head. The coordinator had already read that migration at file 6, and it understood the problem completely. Then it spawned the specialist and said, check the migrations in this pull request. The specialist opened its eyes on an empty desk. No diff, no file list, no idea which column anyone was worried about. So it spent its turns rediscovering what the coordinator already knew and came back vague. Nothing in the system was broken. The handover was just empty. The fix isn't a smarter specialist. The fix is the coordinator handing over what it knows inside that one string. The file paths go in, the error text goes in, and so does the decision the coordinator already reached. It all goes in structured content in one place and sources in another, because attribution doesn't survive the crossing on its own. If a fact isn't in the prompt, then on the far side of that boundary, the fact does not exist. So say the rule the way you'll use it on exam day. Subagents inherit nothing, so the prompt is the handover. Whenever a question shows a subagent behaving stupidly, reach for that line first. The specialist can finally see the next decision is what it's allowed to touch, and here the trap is generosity. The instinct is to hand every specialist every tool just in case, and the guide is blunt about why that backfires. An agent holding 18 tools where 4 or 5 would do picks less reliably because every extra tool is one more way to choose wrong. And it gets worse than unreliable because an agent holding a tool outside its specialty tends to use it badly. Give the security specialist a file editing tool, and one day it quietly fixes the thing it was supposed to report. So each specialist gets the tools its role needs and nothing else. Security gets raid and search. Migrations adds one schema lookup. Contracts gets raid and diff. Then there is one exception, and you make it on purpose. When a specialist keeps needing one small thing from another's territory, it gets one narrow tool for exactly that and nothing more. Hold on to that shape, the scope cross-roll tool. It decides this episode's question. Forcing which specific tool gets called sits here too, but it belongs with tool design, so it has its own episode. The team can see and it can touch. 2 mechanics left, and then Nadia's system is whole. First, a subagent never reports to you. It returns one final message to the coordinator, which decides what it's worth. So when 3 verdicts arrive, merging them is real work that the coordinator owns, not plumbing. Second, parallelism has one precise mechanic on the exam. The coordinator emits several subagent calls inside a single response. One response means the specialists run side by side. Spreading those calls across separate turns means they quietly queue. And there's a background mode on current builds the default, so the coordinator keeps working unless a call says it must wait. That default has moved before, so on a real job, check the build in front of you. Time to sit one, a real published sample from the guide set in a system shaped like the one you just built. A research system has a coordinator, a search agent, and a synthesis agent that writes the final report. While it writes, the synthesis agent keeps needing to check small facts: dates, names, numbers. Each time it hands control back to the coordinator, which calls the search agent, then re-invokes synthesis with the answer. That's 2 or 3 round trips per task, and it's costing about 40% extra latency. One more number from the stem: roughly 85% of those checks are simple lookups, and the rest need real digging. Option A: give synthesis a narrow verify fact tool for the simple lookups and keep sending the hard ones through the coordinator. Option B: have synthesis collect every verification and send them to the coordinator as one batch at the end of its pass. Option C: give synthesis the full set of web search tools so it never has to round trip at all. Option D: have the search agent cache extra context around every source upfront, anticipating what synthesis will want. Name the question first. It reads like an orchestration problem because the stem complains about round trips. But every option is a proposal about which agent may touch which tool. So this is a what can it touch question. And there's no must and no never in the stem, so the elimination rule stays holstered and least privilege decides it instead. C dies first because handing the writer the full search kit is the 18 tools problem wearing a generous face. B blocks the writer's own work because a synthesis pass leans on facts it verified earlier in that same pass. D is speculation because caching ahead only pays off if you guessed right about what someone else will need later. F is the scoped cross-roll tool, the exception made on purpose, and the smallest extra access that fixes the actual complaint. The rare hard case stays on the path that already works. Look at where Nadia's reviewer stands tonight. 1 coordinator, 3 specialists, each with its own instructions and a short list of tools. Every message routes through the middle, the coordinator picks who runs, and the handover carries the findings in full. 2 lines to walk into the exam with. Subagents inherit nothing, so the prompt is the handover. And an agent gets the tools its role needs, never the tools you happen to have lying around. Next time the specialists catch a real bug and Marco's team merges straight past all 3 of them because advice, it turns out, is not a gate. Nadia's specialist caught a real one this week, a migration on the billing tables that drops a column with no backfill. The migration specialist flagged it and the coordinator posted the warning in plain English: needs a security review before this merges. Marco's payments team read that comment, weighed it, called it low risk, and pressed merge a few minutes after the flag went up. Nobody did anything wrong. A comment invites judgment, and Marco's team used theirs. The specialists caught the bug, and the merge went straight past all 3 of them because advice is not a gate. Freeze it right there because a correct warning that shipped anyway is exactly what the exam turns into a question. The question is simple to see. What do you change so the next warning holds? The guide answers with 3 mechanisms and it makes each one its own scored objective. A hook that intercepts the call before it goes out, a handoff that moves the work to someone who can act, and a human who has to sign. 2 of the 3 sit in the biggest domain on the exam, roughly 16 of the 60 questions you'll sit. The third sits in the smallest domain, worth about 9. By the end, you'll read a requirement and name which of the 3 it needs and why the other 2 are the wrong shape. The architect question parked in the corner all episode is the second of the 4. What can it touch? Start with why the comment failed, because the reason picks the mechanism. The guide has one unusually blunt sentence about this. Where deterministic compliance is required, prompt instructions alone have a non-zero failure rate. Read it as an architect. It isn't saying prompts are bad, it's saying a prompt is a probability. The guide sorts your options into two families, and the first is enforcement hooks and prerequisite gates that run whether anyone listens. Guidance is the other family, and a system prompt, a rule file, and a comment on a pull request all live in it together. Nadia already has receipts. On 2 of the last 10 runs, her coordinator posted approval without the security specialist running at all. That's what a non-zero failure rate looks like up close, and it's the cold open as a principle. Advice is not a gate. The first mechanism that can actually refuse sits right on the tool call, so meet the hook. Mechanism 1 is the hook, a program you register against a named point in the run, and it fires whether or not anything asks. That's the whole idea. The events group by how often they fire. A few fire once per session, at the start and at the end, and a few fire once per turn. The busiest shelf fires on every tool call, with extra events for failures and permission requests. 2 of them you'll use by name. Pre-tool use fires before the call goes out, and that's the interception point, because nothing has happened yet. Post-tool use fires after the tool answers, but before the model reads the answer, and the guide tests that gap directly. 3 servers answer with time in 3 shapes. 1 a bare number, 1 a status code with no words in it. A post-tool use hook rewrites them in the return path, and the model only ever sees one format, because the cleanup happened before it looked. Watching every call is useful, but Nadia needs to stop one. So how does the hook actually say no? The hook can see every call. Now the whole course leans on how it refuses one. When pre-tool use fires, the hook reads a small block of JSON on standard input, and 2 fields carry the call, tool name and tool input, the exact arguments. There are 2 ways to say no. The blunt one is an exit code of 2, a blocking error, so the call is prevented and your reason is shown on standard error. The polite one is exit 0 with a JSON decision, a permission field saying allow, or deny with a reason or ask a person. For Nadia, that's a dozen lines. Approval call in, security result missing, exit 2, no approval post. Now the precedence, because hooks and permission rules share this ground, and the exam loves that seam. A hook that answers allow doesn't bypass your rules. A deny rule still blocks, and an ask rule still prompts. But a hook that exits 2 stops the call before the rules are even consulted, so it outranks an allow rule. Compress that into the sentence worth memorizing. A hook can always stop a call, and it cannot open one your rules have closed. One trap before we leave, because a gate can look installed and never exist. A hook registers against a matcher, and plain names with list punctuation match exactly those names. Anything fancier quietly becomes a regular expression, and the expression is unanchored. So a bare server prefix on its own matches no tool, and it has to be a pattern that reaches through to the tool names behind it. So the gate holds and the merge waits, but the work it stopped still needs doing, and a blocked call doesn't do it. Mechanism 2, because blocking is only half a design. The stopped work still has to reach someone who can act. The guide pairs them. A hook that blocks a violation also redirects the work to another workflow. The shape of that redirect matters, because the person receiving it can't see the conversation that produced it. So, a handoff is never a notification. It carries the identifiers, the root cause, and the recommended action. The same objective also covers ordering a prerequisite gate that blocks a downstream call until the upstream step has returned what it should. A gate and an envelope are still machinery talking to machinery. The third mechanism puts a person in the path on purpose. Mechanism 3 is the signature, and the exam treats it as architecture, not a fallback. Permission rules evaluate in a fixed order: deny first, then ask, then allow, and the first match decides. Specificity doesn't change that order. The middle tier is the signature, because an ask rule prompts even when an allow rule also matches. Put an ask on anything touching billing, and the person owns that decision every time by construction. Then the harder half, deciding what the person actually sees, because reviewer time is scarce. The guide's warning is the good aggregate hiding a bad segment inside it. So you measure per document type and per field, and you only automate the segments that earned it. And you keep sampling the cases you trusted, randomly and stratified, so a new failure lands in your sample before it lands in production. And asking the model how sure it feels, then routing on that number isn't calibration at all. Calibration is field level confidence scored against a labeled validation set with thresholds read off the data. Three mechanisms on the bench, so sit the guide's own question and watch which one it asks for. This one is a real published sample from the guide, and it lands square on the ground, the three mechanisms just built. A support agent is supposed to verify who the customer is before touching any of their orders. Production data says that in a small but steady share of cases, it skips the check, looks the order up from the name alone, and refunds the wrong person. Option 1, a programmatic prerequisite that blocks the order, lookup, and the refund until verification has returned a verified customer ID. Option 2, strengthen the system prompt to state that verification is mandatory before any order operation. Option 3, add examples of the agent verifying first, even when the customer volunteers the order number. Option 4, a routing classifier that reads each request and switches on only the tools it needs. Name the question first. Every option decides whether a call may proceed. So this is a what can it touch question. Then find the absolute. And here is this episode's twist. There's no must and no never anywhere in that stem. The absolute hides in the consequence. Money moves on a wrong refund and the failure rate is already stated as non-zero. A stated non-zero failure rate does the same work as a never when money sits on the other side of the rule. Now the eliminations run themselves. The stronger prompt is guidance, the examples are guidance, and guidance can't drive a stated failure rate to zero. And option 2 is worse than wrong. That instruction is already in the system prompt, so it's the thing that already failed said louder. That's Marco's comment all over again. Advice is not a gate, and a second quote of it doesn't make one. Option 4 dies on a different axis because it changes which tools exist when the complaint was about the order they run in, which leaves the prerequisite gate holding the refund until verification returns a verified ID, and that's the guide's answer. Programmatic enforcement gives a deterministic guarantee that prompts can't wherever a tool sequence carries critical business logic. Look at where the system stands tonight. Same team, 3 new pieces, and none of them ask for cooperation. The approval can't post until the security check has actually returned, and that's the hook. Blocked work leaves with a summary a stranger can act on, and that's the handoff. And anything touching billing waits for a signature, nothing else can pre-approve away, and that's the human. Block it when the rule reads off the call itself, hand it off when the work still needs doing, ask for a signature when a person has to own it. Then walk in with the line this episode kept proving. Advice is not a gate, and when a rule has to hold every time you wire it. Next time Marco renames one helper, the reviewer approves it, and a service nobody touched goes down because it can only judge what it's handed. Marco renames one helper function inside the payments module, and the reviewer reads the change and approves it. A while later, a service nobody touched in that pull request stops working. The old name was still being called from 4 other places, and not one of them was in the diff. The reviewer didn't miss those calls. It never had a way to look. All it can see is the text somebody handed it. So when Nadia asks the question that counts, was the rename safe? Nothing inside that diff can answer her. Freeze it right there, because this moment an agent that can't reach past what it was handed is what the exam asks about. The question is simple to say. What do you give an agent so it can reach the systems that hold the answer? That question comes from domain 2. tool design and MCP integration, roughly 11 of the 60 questions you'll sit. The guide splits it into 5 task statements, and this episode covers all 5 because they are one decision in 5 parts. By the end, you'll be able to watch an agent reach for the wrong thing and say which of the 5 is broken. The architect question parked in the corner all episode is the second of the 4. What can it touch? And the first place to look is the toolbox the reviewer is already holding. Start with the tools that already ship because the guide gives them a task statement of their own and it's new. 2 of them search, grep looks inside files at content, so a function name, an error message, an import statement. Glob matches paths, names and extensions, so every test file under a directory without opening one. One searches text, the other searches names, and that's the whole split. 3 more touch files, read and write work on the whole file, and edit makes a targeted change by matching text that has to be unique. That's the exam point, because when the anchor text appears twice the edit fails and the fallback is read then write, which is Marco's rename because a renamed helper is exactly the string a file holds more than once. So point that toolbox at Nadia's question, grep for the old name, read the files that come back, then follow their imports. If the rename crosses wrapper modules, collect the exported names first and search each one. One oddity before you sit. The task statement lists 6 built-ins, including edit, a published scenario lists 5, and items follow the statement. The reviewer can reach the repository now, and it still picks the wrong tool, which is a different failure. The next failure is quieter, and it's the one this episode turns on. 2 of the reviewer's tools are analyze diff and analyze file, and each description is 1 line long. Neither says which to reach for when the change is a rename, so the reviewer guesses the same wrong way every time. The guide's own wording is that tool descriptions are the primary mechanism a model uses to select a tool. Sit with that. The model reads the description before it chooses, so the description is where the choice happens. So here is the line to carry in. A selection problem is a description problem. The documentation calls it by far the most important factor in tool performance and sets a floor of 3 or 4 sentences. Say what it does, when to use it, when not to, what each parameter changes and what it won't handle. 2 more moves right along. Name the service in front of the action, fold a tool per verb into one and split any tool doing too much. Then the trap, a keyword in your system prompt can quietly override a description you wrote well. Say, analyze every change carefully in the prompt and it'll reach for the tool with analyze in its name. Fix the descriptions and the repository is covered. Nobody on Nadia's team owns the tracker, though. So this is the boundary and MCP is how the reviewer crosses it. 3 roles, because the exam wants the words. The host is the application, a client holds one connection, a server provides context. A server hands over 3 kinds of thing. Tools that do something, resources that are data, and prompts that are templates. Resources are the one people skip, and the guide calls them out. A catalog of issue summaries kills a pile of exploratory calls. So tools are how the agent acts, and resources are what it can see without asking. Then scoping close to a guaranteed item. A shared server goes in the project file at the repository root, a personal one in your user config. Credentials never sit in the checked-in file because it expands environment variables, and every configured server's tools go live at once. So see the scoping rule the short way, shared in the repository, personal in your home, secrets in neither. For a standard integration, take the community server that exists and describe its tools well enough to beat plain grep. One piece of that connection is still open, and it's the piece I taught wrong the first time. It's the transport, the wire a server actually talks over, and it's where I owe you a correction. There are 2 active transports. One runs a local process and talks over its standard input and output. The other is HTTP, a post for each message with an optional streaming response when a server answers in pieces. Here is the trap, and its terminology rather than mechanics. One three-letter name means that streaming response inside the HTTP transport. The same three letters also name an older standalone transport that's being retired. So one name covers a live piece of one transport and a whole dead transport, and an item can lean on either. So don't memorize a count of transports. Work out which of the two the stem means. One rider. Claude Code also accepts a WAP-socket transport for a server that pushes events without being asked. Now the reviewer is finally connected and the tracker picks tonight to fall over. The tracker goes down for about a minute. Its tool returns one word, failed, and the reviewer escalates to a human. Nothing was broken. It needed to wait and call again, and that result gave it no way to know. So errors get a shape. The flag on the result says something went wrong, and what happens next comes from what you put beside it. Sort failures by kind. Transient means the service was unavailable. Validation means the input was bad. Then permission, which means it wasn't allowed, and a business rule, which means the answer is simply no. Return the category, return whether it's worth retrying, and return a sentence a person could read. One uniform failed across all four is why the reviewer guessed, and that guess was a retry that never had a chance. For a policy violation, mark it not retriable and say why in customer-friendly words. A subagent fixes its own transient failures and passes up only what it can't, with a partial result, and an empty result isn't a failure. The reviewer can reach and it can fail properly, so what's left is how much any one agent should hold. The fifth statement is how you spread tools across agents, and you met half of it 2 episodes back. An agent holding 18 tools selects worse than one holding 4 or 5, and a tool outside its specialty gets misused. So each subagent gets its roles tools, one narrow cross-role tool for a constant need, and a constrained version of anything general. The new half is tool choice. 3 settings. Auto lets the model decide, and it may answer in plain text without calling a tool. Any guarantees a call, and force names the exact tool, which is how you make one specific call happen first. So auto is a suggestion, any is a promise, and fast is an order, and a stem about a model chatting instead of calling wants any. That's all 5. Sit a real one and see whether they hold. This one's a real item from the guide's published samples. A support agent has 2 tools, get customer and lookup order, and the logs show it calling get customer for order questions. Both descriptions are one line, both take similar identifiers, and the stem asks for the most effective first step. Option A. Add few short examples to the system prompt showing order queries routing to the right tool. Option B. Expand each description with input formats, example queries, edge cases, and when to pick it over the other. Option C. Build a routing layer that reads the user's input and pre-selects a tool from keywords and identifiers. Option D. Consolidate both tools into one that takes any identifier and works out which backend to query. Name it before you answer. This is a what can it touch question, and inside it, tool interface design. There is no must and no never in the stem, so the elimination rule stays holstered. 2 words decide this one instead, and those words are first step. C dies first because a routing layer steps around the language understanding you are already paying for. D is a real architecture and much bigger than a first step, while the descriptions are still the problem. A cost tokens on every call and leaves the cause alone, which is that neither description says what its tool is for. B is the answer. Lowest effort, highest leverage aimed straight at the cause instead of around it. There's the line again on a real item. A selection problem is a description problem. Look at where the reviewer stands tonight. It started this episode able to read a diff and nothing else. It has the built-in tools for the repository and servers for what it doesn't own, and its errors carry a category and a retry flag. Every agent holds a handful of tools, and Marco's rename gets caught because the reviewer can grab the old name outside the diff. One line to walk in with, A selection problem is a description problem. Next time, 3 teams pick this up and run it 3 different ways, and none of them agree on the rules. The reviewer just left a comment on a test file telling the author to use the repository pattern. That pattern belongs to the database models 3 directories away, and this test never touches a database. Nothing crashed and nobody wrote a bug. The reviewer read the rules it was given, and the rules never said where they applied. One engineer set it up on his machine, and for him it worked. 2 more teams started running it, and a new hire on the platform team got none of the conventions at all. Freeze it right there, because the gap between those 3 desks is what this exam turns into a question. Where do you write a convention down so the right one reaches every file it applies to on its own? That question comes from domain 3 on the exam, configuration and workflows, roughly 12 of the 60 questions you'll sit. This episode owns 3 of its task statements, and the rest of the domain is the next episode. The instruction hierarchy, custom commands and skills, and path scoped rules that load only where they apply. The coverage map, every task statement against its episode, is in the description. The architect question part in the corner. All episode is the second of the 4. What can it touch? Configuration is that question answered in files. So start with where Claude code actually reads them. Start with what broke, because the fault picks the fix. The instruction file is called cloud.md, and several load at once. Broadest first, narrowest speaking last, closest to the work. At the top sits a managed policy file, placed by whoever runs the machine, and no project can reach up and rewrite it. Under that, your own user file in your home directory inside .claude. Then the project file, either at the repository root or inside the project's .claude directory. Then a skillout.md inside a subdirectory. So one corner of the code base can carry rules of its own. And last, a local file which is yours alone and stays out of version control. Now replay the new hire. The first engineer wrote every convention into his user file, and on his machine that worked. A user file belongs to one user on one machine, and it never travels through version control. So the new hire cloned the repository, and the reviewer arrived with none of the conventions. Nothing in the repository looked wrong, because the conventions were never in it. The guide lists that exact diagnosis as a skill, and the shape repeats all over this domain. The instructions themselves are correct, and it's the scope that's wrong. The fix is one move. Team rules live in the project and get committed, or they don't exist for anyone else. And you never guess, because /memory lists every memory file that's loaded with its scope. So every rule moves into the project file, and the file starts to grow. The team's rules all sit in one file now, and everything in that file loads every time, whether the task cares or not. The exam expects 2 ways to break it up, and the first is an import. An @ sign followed by a path pulls another file's content straight into the instruction file. That lets each package in a monorepo pull in only the standards its maintainer actually needs. The second is a rules directory .claude/rules, holding one small file per topic. Testing in one file, API conventions in another, deployment in a third, not one monolith with headings. To a human, the two look the same, but only the rules directory can be made conditional, and that's an exam question. Hold that thought, because a second filing system sits next to yours and you didn't write it. There's a second memory system next to the instruction file, and mixing the two up is an easy mark to drop. Claude.md is what you write. Auto memory is what Claude writes for itself, out of your corrections and your stated preferences. It's on by default. It lives outside the repository, and it's shaped like an index with topic files behind it. The index top loads at the start of every conversation, and the topic file loads only when it turns relevant. Your standards are deliberate, written, and committed. Auto memory accumulates, which makes it the wrong home for a team rule. So deliberate rules live in files you control, and that pays off next, because a rule file can learn to stay quiet. Here is the piece older material tends to miss, and it's the answer to a published question on this exam. A rules file can carry front matter, and that front matter can hold a paths field which takes glob patterns. When the file being worked on matches the pattern, the rule loads. When it doesn't match, the rule never enters context at all. A rule scope to the Terraform tree stays silent everywhere else in the codebase. Two things follow, and both are scored. The first is less irrelevant context, less spent on conventions the task never needed. The second is sharper, and it's the beat this episode exists for. A glob isn't tied to a directory at all. Think about where test files live. Right beside the code they test, in every folder of the tree. Now try to cover them with a subdirectory instruction file. That file reaches its own directory and nothing else, because a directory file is bound to the place it lives in. You'd need a copy in every folder, and the copies would drift apart within a week. A pattern doesn't have that problem. One glob that matches every test file wherever it lives describes all of them in a single rule. So say the rule the way you'll use it on exam day. The rule matches a pattern, not a place. Convention follows a directory file is fine. Convention follows a file type, you need a path scoped rule. Rules now find their own files. The next thing a team shares isn't a rule at all, it's something a developer types. A custom / command is just a file, and where that file sits decides who has the command. In the project under .claude / commands, it's committed, so everyone has it the moment they clone or pull. In your home directory, it's yours alone, and no teammate ever sees it. That's a shape you already know. The location is the sharing model. The guide asks exactly this, and the answer is the project's commands directory, shared the moment anyone pulls. Two distractors are worth naming. The instruction file holds project context, it doesn't define commands, and a config file with a commands array in it just doesn't exist, which is a distractor shape you'll meet again. One more thing here, because it's recent, custom commands have been folded into skills. A commands file called review and a skill folder called review both give you /review, and they behave the same. Which raises the obvious question, if a command is just a skill now, what exactly is a skill? A skill is a directory under .claude /skills with a skill.md inside and supporting files alongside. The property that matters is when it loads. A skill's body stays out of context until the skill is used. The instruction file is the exact opposite, loaded always for every task, relevant or not. So the choice is universality. Universal standards go in the instruction file. Task-specific workflows go in a skill. Front matter controls a skill too. An allowed tools list narrows what it can call, so an analysis skill can't write a thing. And a fork option runs the skill in an isolated subagent, so a noisy skills output never lands in the main conversation. Now the three come apart. A command is the name you type, and a skill is the body that loads when it's needed. A subagent is a separate context with its own window, and a skill can be told to run inside one. So a skill isn't a subagent, it can use one, and that difference is often the whole question. That's the whole toolkit. So walk it into the guide's published question. Here is that published question, run at the speed you'd actually use. 3 areas: components in a functional style, API handlers with their own error handling models on a repository pattern. Test files sit beside the code they test, all through the tree, same conventions everywhere. The stem wants the most maintainable way to apply the correct conventions automatically when code is generated. Name the question first, what can it touch? Because every option decides what enters context and when. Option B consolidates every convention into the root instruction file, one heading per area. That loads everything every time and then hopes the right heading gets picked. Hoping isn't matching. B infers, so B is gone. Option D puts an instruction file in every subdirectory, and for the three main areas, it works. Then it reaches the test files, which live in every directory at once, while a directory file is bound to exactly one. The rule matches a pattern, not a place, and D can't see a pattern, so D dies on the tests. Option C builds a skill for each code type with the conventions inside it. But a skill loads when it's used, and the stem set automatically, decided by the file path, gone, which leaves a rule files with glob front matter matching on the path itself. One pattern covers every test file regardless of folder, one scope rule per area. That's the answer. Notice the word that did the work, automatically it killed the option that needed somebody to choose. Look at where those three desks stand tonight. One committed project file, rules that load only for the paths they match, and skills for what isn't universal. And the test file from the cold open finally gets the right comment. From a rule scope to test files. 2 lines to walk into the exam with. Anything the team depends on lives in the project and gets committed. And when the files are scattered, the rule matches a pattern, not a place. Next time, the same system runs with nobody watching, and the question becomes how far you let it go alone. Marco's team merged a payments change at 2 in the morning, and the reviewer never looked at it. Nothing was broken. The reviewer works fine. It just sat there because nobody was awake to type into it. Every step of this system has quietly assumed the same thing. A person at the keyboard saying yes, freeze it there because a review that only happens while somebody's awake is exactly what this exam asks about. Nothing broke, so what has to change about where this review runs? That question lives in domain 3, configuring and running Claude code, and it's a fifth of the whole exam. Call it roughly 12 of the 60 questions you'll sit. The guide splits the domain into 6 task statements. The previous episode took the first 3, and this one takes the rest. First, when to gate a change behind a plan instead of just letting it run. Second, what you actually do when a run comes back not quite right, and that one scored, not a pep talk. And third, how the reviewer runs with nobody watching, which is where the 2 in the morning merge gets fixed. The architect question parked in the corner all episode is the one the cold open asked. Where does the work run? Start with the vocabulary because items here name these modes and expect you to know which does what. There are 6 permission modes and the documentation names them default, accept edits, plan, auto, don't ask, and bypass permissions. Default reviews each action that would change something and asks you first. Accept edits pre-approves file edits and the common file system commands. Plan mode has Claude research and propose changes rather than make them, and it gets its own section. Auto mode puts a background classifier in front of the decision and it approves what passes its safety checks. Don't ask denies anything that wasn't already pre-approved instead of stopping to ask. And bypass permissions skips the checks altogether, which you do to a disposable container, not a laptop with live credentials. One naming trap. The mode written default in configuration is labeled manual in the interface and hooks still receive it as default. Same mode, 2 names. Match the string the question uses. One exception runs under all 6. A small set of read-only shell commands never prompts in any mode and the set isn't configurable. So an option claiming some mode stops Claude from reading the repository is describing a feature that doesn't exist. That's this episode's rule in miniature. If you can name the real mechanism, an invented one stops being tempting. Modes are the coarse dial. One layer down sits the single rule and rules hide a surprise. So here is how a single rule works. It names a tool and a specifier in brackets can narrow it to a path or a value. The order is fixed. Deny first, then ask, then allow, and the first match decides the outcome. Here is the surprise. How specific a rule is doesn't move it up that order. So a broad deny beats a precise allow every single time. One more is shaped exactly like an exam question. A repository can't hand itself the looser mode by writing it into the project settings file. Claude Code ignores that on purpose. The looser posture has to come from the user's own settings. A checked-in file that quietly widens what a run may do is the attack, so the product refuses to read it from there. Posture and rules say what a run may do. Next is the decision the objective names outright: plan the change or just make it. Plan mode first. Plan mode tells Claude to research and propose changes without making them, and edits stay blocked until you approve the plan. The guide is blunt about when that's right. Large scale change, several valid approaches, architectural decisions, edits spanning many files. Direct execution is for the small, well scoped change. One function, one validation check, a stack trace pointing at the line. So the test isn't how risky the change feels, it's whether you already know the shape of the answer. The guide even names a companion for the exploring part, the explore subagent. It keeps the noisy discovery out of the main conversation and hands back a summary. The guide publishes a question on exactly this. The stem, a monolith to restructure into microservices, dozens of files, boundaries undecided. One option says start executing and let the boundaries reveal themselves, which is how you find a dependency after you've built around it. Another says write comprehensive instructions up front, which assumes you already know the structure you're trying to discover. The third says start direct and switch to plan mode later. But the complexity isn't coming later, it's stated in the stem. So the answer is plan mode, entered first to explore and design before a single file is touched, because the shape wasn't known. One caution, because prep material overreaches right here, plan mode is a gate on your workflow. If the requirement is that something can never happen, you need a mechanism, a deny rule, or a hook that blocks the call. Then the plan's approved, the run happens, and it comes back not quite right. The middle objective looks soft on the list, and it's scored like the rest. Iterative refinement. The run came back not quite right, and what you do next has wrong answers in it. The guide calls the first technique the most effective. When prose keeps getting read differently, stop writing prose. Give it 2 or 3 concrete examples of the input and the output you want. Second, test-driven iteration. Write the tests first, covering the behavior you expect, the edge cases, and the performance you need. Then iterate by handing back the failures, a specific target instead of a vague complaint. Third, the interview pattern. Have it ask you questions before it implements, surfacing decisions you didn't know you were making. And one that shows up as a question more often than you'd expect. Several problems at once or one at a time. If the fixes interact, put them all in one detailed message, because repairing one alone will break another. If they're independent, go one at a time and keep each change small enough to tell what caused what. All of that still has you in the room. The next objective takes the chair away. Here is the mechanism for running it with nobody there, and it's one flag. Add -p or its long form print, and any Claude Code command runs non-interactively. It takes the prompt, does the work, writes the result to standard output, and exits. It exits 0 on success and non-zero on failure, the only thing a pipeline step really needs from it. The flags around it matter too. Output format takes text or JSON or stream.json for the events as they happen. The guide pairs the JSON output with a JSON scheme flag, so findings come back in a shape a script can post as inline comments. Allowed tools narrows what the run may call, permission mode sets its posture, and continue picks up where the last session stopped. And precedence matters. A command line flag outranks the project's settings file, so a pipeline sets its own posture at the call site. That's the flag in a shell script. The supported way in goes a step further. That way is an action Anthropic publishes, and it runs Claude code inside the repository's own workflows. Mention Claude in a pull request comment, and it analyzes that code in the thread, makes changes, and can push commits. Or the workflow hands it a prompt, and it runs with nobody asking, which is the 2 in the morning case. A pipeline run has no U in it, so the project's instruction file is the only way that run learns your standards. Your testing standards, your fixtures, what your team counts as a finding worth raising. If it is not written down, that run does not have it. The session that wrote the code is worse at reviewing its own changes than a fresh, independent one. So the review always gets a run of its own. And that's every piece in place, which means it's time to sit the question this episode was built for. Here it is, straight from the guide's own continuous integration scenario. A pipeline script runs Claude with a prompt, asking it to analyze a pull request for security issues. The job hangs indefinitely. The logs say what Marco's logs would have said. Claude code is waiting for interactive input. Name the question first, the way you have all episode. The prompt is fine and the tools are fine. What's wrong is where it's running, so this is where does the work run. Now watch what knowing the real mechanism does to 4 options. One option sets an environment variable that declares the run headless. Another adds a batch flag. Neither of those exists. They're not bad ideas you weigh and reject. They're features somebody invented for this question. If you can name the real mechanism, an invented one stops being tempting. The third option redirects standard input from dev null, the Unix reflex, and it silences the symptom instead of fixing the interface. The answer is the print flag, add -p, and the run is non-interactive by design, which is precisely what the pipeline needed. 2 invented features, 1 workaround, 1 real mechanism. That shape is the most common way this domain gets tested. Look at where the system stands tonight. It can tell planning a change from making one, it runs with nobody present, and it reviews every pull request in the pipeline. The 2 in the morning merge can't happen again because the review no longer waits for anyone awake. 2 lines to walk into the exam with. A run's posture comes from modes plus rules, and rules evaluate, deny, then ask, then allow. And if you can name the real mechanism, an invented one stops being tempting. Next time the reviewer starts flagging things that aren't problems, because a reviewer that cries wolf is its own kind of failure. Marco added a filter to his inbox this morning, and the thing it filters out is the reviewer we built. It ran on his payments pull request overnight and left 19 comments, and only 3 of them were real. The other 16 were style opinions, plus a warning about a pattern this repo uses everywhere on purpose. The security bug it did find sits at comment 14 of 19, where nobody will ever read it. A reviewer that's right sometimes and loud all the time is worse than no reviewer at all. Freeze on that one comment, because the exam is built out of moments exactly like this one. The question sounds simple. What do you change? So the 3 real findings become the ones people actually read. And hold your first instinct, because the fix here isn't a stronger instruction. The reviewer runs by itself on every pull request now, but it can't stay quiet about what doesn't matter, and that one failure cancels the rest. This is domain for prompt engineering and structured output, a fifth of the whole exam, call it roughly 12 of the 60 questions you'll sit. The guide even wrote this story down as one of its scenarios, prompts that give actionable feedback and minimize false positives. The weight makes sense, because the documented way to change how the model behaves is the prompt itself, not a knob on the request. The architect question parked in the corner all episode is, how is the intent carried? Before touching a word of that prompt, you need to see why 3 real findings still lost the room. Start with the score. 3 real problems out of 19 comments isn't a terrible hit rate for a first version. The team stopped reading anyway. The guide explains it in one knowledge bullet. A category with a high false positive rate undermines confidence in the categories that are accurate. So the noisy style check took the security findings down with it. Marco's filter doesn't care which category was the honest one, which unlocks a move the guide lists as a skill you are tested on. Turn your worst category off on purpose. and leave it off while you rewrite the prompt behind it. So style goes dark, trust starts to recover, and now somebody has to open their prompt and find out why it shouts. Here is the prompt, and the cause is written into it in plain sight on the very first line. It reads in capitals, Seattle, you must report every possible issue you find. Read that as a person, and it sounds responsible, but read it as an instruction, and it's an order to never stay quiet. Now, the twist, because nobody wrote that line to be careless. An earlier generation of models underreported, and back then it honestly took hard language to make them speak up. Current guidance says exactly that kind of wording now over triggers. So the cure for the old failure is causing the new one. Same idea as a principle, a prompt tuned around one generation's weakness quietly becomes the next generation's bug. And the documented fix looks like doing nothing. The capitals come out, the thread comes out, and a plain description of the job stays. Report bugs and security issues. That's the entire replacement. The rest of the block gets the same treatment, say what you want done, instead of listing everything you don't. A quieter sentence feels wrong at first, and it felt wrong to Marco's team. So their next patch adds more words. The added words are the two lines everyone reaches for: be conservative and only report high confidence findings. The guide names both of those lines and says plainly that they fail to improve precision. Both lines ask the model to grade its own certainty, then filter its own output on that grade. The model sounds equally certain either way, whether it's wrong about a naming convention or right about a real bug. What works is changing the instruction, not the volume, and the guide's own example is two versions of one line. Version 1 says check that comments are accurate, which sounds fine, but leaves the model to decide what accurate means. Version 2 says flag a comment only when the behavior it claims contradicts what the code does. The second one is testable. You and the model agreed in advance on what counts as a finding, and the guide wants the rulebook built that way. Now build the rulebook, and Objective 4.1 gives it a shape you can draw. Two lists, not a threshold. On the report list go bugs and security problems, and on the skip list go minor style points and patterns local to this codebase. That second entry is Marco's pull request, a pattern flagged as wrong for being unusual in the repo where it's house style. A local convention isn't a defect, and a written skip rule just worked that out where no confidence threshold ever could. Severity gets the same treatment, a concrete code example pinned to every level, an actual snippet, not a definition, so classification stops being a judgment call. One more sentence per rule, say why it exists, because the reason improves compliance, and the model generalizes from it to the case your rule never quite covered. Even this rulebook runs out somewhere, and it runs out exactly at the hard calls. So the criteria sheet cracks on two cases: the finding that's true but not worth posting, and the bug that looks like the local convention. Here the guide is unusually blunt. When detailed instructions still give inconsistent output, few short examples are the most effective technique. Each example is aimed at a boundary, a case where two answers were both plausible, and it shows the reasoning that picked the winner. The cards also carry the output shape, location issue, severity, and suggested fix, so the format gets demonstrated instead of described. The strongest pairs put an acceptable pattern right beside a genuine issue that looks almost identical to it. And it's no lookup table. The guide's own wording says examples let the model generalize judgment to patterns you never spelled out. So you write one example per boundary, not one per rule, wrap each in example tags, and keep the set relevant and genuinely varied. Here is the whole method. Set the way you'll use it, write the boundary down, then show it the hard calls. All that's left is where the words live, and placement decides what every single review costs. The rulebook's written now, so it needs a home, and everything that's true on the first turn of every review goes in the system prompt. The turn underneath holds one thing: the diff you want reviewed. If a rule only matters later, a mid-conversation system message carries it with the same authority. Inside the turn, the long material sits near the top and the ask goes last, so the diff comes first and the instruction lands freshest. And every block gets its own tag, so instructions, criteria, examples, and the diff can't bleed into one another. There's a cost reason too. The cached prefix builds in order, tools, then system, then messages, and a change invalidates everything after it. Put the pull request number at the top of the system block, and you pay full price again for every stable word underneath it. The prompt is rebuilt, so let's watch the exam ask about all of this at once. Time to sit 1, a published sample straight from the guide, the actual item, not my imitation of one. A support agent resolves barely half of its contacts on the first touch, well short of its target. The way it misses is the tell. It escalates easy cases with photo evidence and tries to handle the policy exceptions itself. So the boundary between resolve and escalate lies in somebody's head, and nobody wrote it down for the agent. Name the question first. The agent holds the case and picks the wrong action. So this is a how is intent carried question. Then check for an absolute, a must, or a never. There isn't one. The stem only asks for the most effective way to improve escalation calibration. No absolute means guidance is legal, and in this domain guidance usually wins, the exact opposite of the last few episodes. Option B has the agent score its own confidence and wrote the low scores to a human, which is the same idea that already failed on the reviewer. A self-reported score is poorly calibrated, and this agent is already confidently wrong on the hard cases, so B filters with the broken part. Option C trains a separate classifier on historical tickets, labeled data, and a second model bought before the cheap prompt change has even been tried. Option D escalates on customer sentiment, which is a different problem. An angry customer with a simple return is still a simple return, which leaves a explicit escalation criteria in the system prompt with few short examples showing when to escalate and when to resolve. A wins because it names the root cause, an unwritten decision boundary, and the explanation calls it the proportionate first response. Look at what a really is, our line in exam clothes. Write the boundary down, then show it the hard calls. One twist before we leave it. Make the stem say the agent must never resolve a policy exception, and it dies on the spot. Never is a promise a prompt cannot make, so the moment an absolute enters the stem, only a mechanism can answer. Look at where the reviewer stands tonight. A report list and a skip list, a snippet on every severity level, and examples for the hard calls. Its worst category is still off on purpose, and Marco has taken the filter off his inbox. One line to walk out with for any system where the output is wrong and the instructions look right. Write the boundary down, then show it the hard calls. If nobody has done either, you don't have a model problem, you have a prompt that never decided anything. Next time the reviewer writes its clearest report yet, and Nadia's merge gate can't read a word of it because the gate doesn't speak prose. The reviewer wrote a good verdict last night, and Nadia's merge gate threw it away without reading a word. 2 clean paragraphs about a missing null check in payments handed to a script that doesn't read English. The gate looks for a decision and a severity, finds neither, and lets the merge through, which is the worst default it has. Freeze right there, because that fallback is the moment the exam is asking about. Nothing in the review was wrong. It was written for a human, and no human was in the path. So here is the actual question. What has to change so a program can read what the reviewer just wrote? This is where output stops being for a person and becomes an input to a program. Prompt engineering and structured output is the 4th domain of the exam. A 5th of the whole thing, roughly 12 of the 60 you'll sit. This episode owns 3 of its task statements: structured output through tool use and schemas, validation and retry, and batch strategy. By the end, you look at a requirement and know which of those 3 it needs and why. The exam is built on 6 published scenarios, and structured data extraction is one of them, one of the two with no published sample questions. The architect question parked in the corner is the third of the four. How is intent carried? Write the requirement in Nadia's words first, because the wording picks the answer. The gate must never receive a verdict, it can't parse. You know what must never does to a list of options, so asking for JSON in the prompt is out, and so is a careful instruction. Both of those work most of the time, and most of the time isn't never. The mechanism the guide names is tool use with a JSON schema, and the trick is where you read the answer from. You define a tool whose input parameters are the shape you want, then read the answer out of the tool call instead of the text. The guide calls that the most reliable route to schema compliant output, and it eliminates JSON syntax errors. The principle under it: once a program is downstream, shape is the lever, not wording. A second mechanism gets confused with this one, and they're complementary. Output format shapes what the model says, strict mode shapes how it calls your functions. One request can use both. One naming trap rides along. The format sits inside an output config object now, next to effort, and needs no beta header. Two limits on the schema itself. Objects must declare no additional properties, and recursion, numeric ranges, string lengths, and external refs return an error. So the shape is defined. That doesn't mean the model will fill it in. Whether the tool gets called at all is a separate setting, and tool choice has 4 of them to pick between. Auto lets the model decide and is the default the moment you provide tools, so auto can hand you the paragraph the gate just dropped. Any means it has to call one of your tools. Tool means the one you name, and none stops it calling tools at all. Several schemas and no idea which document is arriving. That's any. One extraction that must finish before an enrichment step that's forcing it by name. Now the piece that catches experienced people: pre-filling the assistant turn, writing the start of the reply yourself, errors on the current model line. Where pre-fill really was the mechanism, use a schema for format and a tool with an enum field for classification. Prefill moved rather than left, because forcing a tool makes the API prefill the assistant message itself, and that's what makes the call happen. So under force tool, use the model says nothing before the call, even if you asked it to explain, and nothing errors to tell you. And only a trailing assistant message counts as a prefill, so few short assistant turns mid-conversation are fine. None of that says whether the contents are true. A schema that validates isn't a schema that's right, and that's where extraction systems fail. Mark a field required and the model has to put something there, so a document that doesn't carry that fact gets a value invented to fit. You've turned a missing field into a confidently wrong one, so any field the source might not carry has to be optional or nullable. Closed lists fail the same way, so add an unclear value for ambiguous cases and another value with a free text detail beside it. Messy source formats get a normalization rule in the prompt, never in the schema. The schema enforces, the prompt explains. On the reviewer that becomes 4 named fields: a location, the issue, a severity from a fixed list, and a suggested fix. Nadia's gate stops parsing English and starts reading fields. And that's the first version of this that holds. A schema guarantees the shape. It's about to turn out that it doesn't guarantee the truth. Here is the sentence from the guide I'd put on a card. A strict schema eliminates syntax errors, and it does not prevent semantic errors. Sit with that, because it's worse than it sounds. The extraction parses, every field is the right type, and the line items don't add up or a value sits in the wrong field. No schema catches either one, because nothing about them is malformed. It's well formed and wrong. So say it the way you'll use it on exam day. A schema guarantees the shape, it doesn't guarantee the truth. Validation is your job then, and the guide's move makes the model help. Have it produce the same number twice. Ask for the total the document states, and separately for a total calculated from the line items, then let your code compare them. A mismatch becomes a flag your code can act on instead of a silent error. And ask for a boolean the model sets when the source contradicts itself, so bad input announces itself. You are not asking the model to be right, you are asking it to hand you something you can check. So, what do you send back when the check fails? A bare retry sends the same document and gets the same answer. So, what goes into the second request matters more than the retry. A retry with feedback carries three things: the original document, the extraction that failed, and the specific validation errors. The model isn't extracting anymore, it's correcting, and correcting is easier than starting over. Here is the limit, and it's where items get written. Retrieving fixes format and structure, and it doesn't fix missing information. If the number only exists in a document you never sent, every attempt either fails or invents, so a loop with no cap is a bill. One extra field turns the loop into something that improves. Every finding carries the code pattern that triggered it. When Marco's team dismisses one, you know which construct produced it. So false positives become a sorted list. That loop runs whenever somebody opens a pull request. The overnight work is different. The last piece looks misfiled in a prompting domain, but batch processing is an architecture decision. There's a batch route that costs far less than calling in real time, and it's far slower, with no guaranteed completion time at all. The rule is short, and it's about who's waiting. If a person or a merge is blocked on the result that's real time, and everything else is batch, every request carries an identifier you assign, and results match back by that identifier, never by the order they return in. When part of a batch fails, you resubmit only those, and you change something first, like splitting a document that ran too long. A batch request can't run a multi-turn tool loop inside itself, so work needing tools executed mid-request doesn't belong there. Refine the prompt on a small sample first, because a first pass problem in a big batch is thousands of mistakes. That's the design done. Now sit an item on it. This one comes from the guide's published samples, and a team wants to cut the cost of its automated analysis. 2. Workflows run on real-time calls. One is a blocking pre-merge check developers wait on, the other, a debt report generated overnight. The manager wants both moved to batch for the savings, and you evaluate that. 4 options. Move both and poll for completion. Move both with a fallback to real time if batch runs long. Keep both on real time to avoid batch ordering problems, or move only the overnight report. Start with the option that dies on a fact, because ordering problems don't exist. Results correlate by the identifier you attach. Poll and move both goes next, because polling doesn't make a slow route fast, and someone is waiting on that check. The fallback option buys a second path, a timeout and a retry into real time to save money on a workflow that can't use batch. Which leaves the unexciting option, and it's the right one. The overnight report goes to batch, the blocking check stays on real time. Keep the shape, not the answer. Each workflow matched to the route its latency tolerance allows, one system and two routes. Look at where Nadia's system stands tonight, because it isn't the one that opened. The verdict is a schema instead of a paragraph, with fields the gate can read, optional wherever the document may be silent. A validation step compares what the model stated against what it calculated, and the retry carries the errors back with it. The overnight analysis moved to the cheap route, and everything a person waits on hasn't moved at all. 2 lines to walk into the exam with. A schema guarantees the shape, it doesn't guarantee the truth. And batch is decided by who's waiting, never by what it saves. Next time, the thing quietly true for several episodes. All of this works because the repository is small. Hour 2 on the big payments repository, and Marco asks the reviewer why the refund path validates twice. It says services of this kind typically validate at the boundary and then again before the write. Typically, it read that file 40 minutes ago, and now it's describing a pattern instead of the code. He asks again and gets a different answer. Both plausible, neither one tied to a line in the repository. Nothing crashed, no error came back, and this reviewer was excellent on a small repository this morning. Freeze it right there. because that vague answer is an exam question, and here is how it gets asked. An agent explores a large code base over a long session, and late on it answers from typical patterns instead of the code it read. Which mechanism keeps the specific findings? That's the failure with no error message, and it lives in the smallest domain on the exam. Domain 5, context management and reliability, roughly 9 of the 60 questions use it. It owns two task statements: preserving critical information across a long interaction and managing context in a large code base. By the end, you'll know which of three mechanisms a problem needs, and most people think there's only one. The architect question parked in the corner all episode is the last of the four. What survives? Start with the window, because all three mechanisms are fighting over it. It holds the system prompt, every message you send, and every tool result, image, and document that comes back. It holds your tool definitions too, and the turn's own output, thinking included. A bigger window doesn't buy a better answer, because as the token count grows, accuracy and recall degrade. The documentation has a name for that slow decay, and the name is context rot. That's Marco's morning and Marco's afternoon. Same reviewer, same code, and the only thing that changed was how full it got. So match the window to the workload and treat it as a budget you curate. Three mechanisms do that curating, and telling them apart is most of this domain. This is the part most preparation gets wrong, so it's worth going slowly. The first is compaction, and it's the platform's primary strategy for a conversation that runs long. It runs on the server, it fires when the input crosses a token threshold you configure, and it replaces the history with a summary. So one verb carries compaction, and the verb you want is summarize. The second is context editing, and it doesn't summarize anything at all. It clears blocks instead. The stale tool results a long run piles up, and the model's own thinking blocks. So one verb carries context editing too, and the verb you want is clear. Those two sit under the same context management setting, and that's exactly why people take them for one feature. The third is memory, and it's a different category of thing. Compaction and editing shrink the conversation you're already inside, and memory outlives it. You declare memory as a tool. Claude asks for file operations, and your own application performs them. One verb for memory. It persists. Compaction keeps the active context small, and memory preserves what has to survive summarization. That second half is the line this whole episode turns on. If it has to survive, it can't live in the history. Two of the three ask something of your code in return, and that's where implementations quietly break. Compaction asks the most, so start there. The response comes back with a compaction block inside it, and you pass that block back on the next request. From there, the API ignores every content block before it, so that block is the seam in the conversation. The bug's easy to write. You append only the text. Everything keeps working, and the compaction state quietly disappears. So append the whole response content. Context editing asks nothing of you because the server applies it before the prompt reaches the model, and your client keeps the full history. Memory plans for it instead, because the API injects a protocol as soon as the memory tool is in your tools. That protocol tells Claude to read its memory directory first and to assume its context can be reset at any moment. That's the platform half of this domain, and the other half isn't a platform feature at all. Here is the half nobody prepares for. All three of them compress something, and compression is where the specifics go. The guide's blunt about it. Amounts and percentages and dates and what a person actually said get condensed into something vague. On this system, it's the same shape. The invariant Marco stated at the start comes back as there were some validation concerns. So stop letting those facts live in the history and extract them into a block of their own that goes into every prompt. That block sits outside the part that gets summarized. So whatever happens to the narrative, those lines survive in full. That's the rally line doing real work. If it has to survive, it can't live in the history. A model handles the start and the end of a long input reliably. and it drops findings out of the middle. So put the key findings on top with section headers down the detail below, and trim a verbose tool result to the fields that matter, because a lookup hands back every field when a handful are relevant. All of that keeps the facts alive inside the conversation, and the strongest move takes them out of it. Back to Marco's repository, where the guide describes his symptom exactly. In extended sessions, the model answers inconsistently and starts referencing typical patterns rather than the classes it found earlier. Typically, that's the same word printed in the blueprint. The move is a scratchpad file, and the agent writes its key findings into it as it goes, then reads it back before answering later. Every line in there carries the path it came from, and that's the part that matters. A remembered finding and a recorded one look identical until somebody tests them. Delegation comes next, and it sends the verbose reading into a subagent while the main agent keeps the high-level picture. The subagent spends its context on the file contents and hands back a short answer, so the main window stays clean. Summarize a phase before the next one starts and inject that summary into the opening context of the next phase. And Claude Code has a compact command for a session that's already filled with verbose discovery output. One mechanism left, and it's the one candidates reach for when they should be reaching for a notebook. Prompt caching is the last piece, and this exam treats it as a fact about structure, not cost. A cache matches a prefix built in a fixed order, tool definitions, then system, then messages. Each level builds on the one before it, so a change at one level invalidates that level and everything after it. Change a tool definition and the whole cache is gone because they sit at position 0, so stable content goes first. Now the fact worth memorizing about caching and the context window. A cached prefix still occupies the window, so caching changes what you pay for those tokens, not whether they count. Verify it in the usage fields, because there is a per model minimum prefix length, and under it caching silently doesn't happen. That's every mechanism in the domain. Here is an item with 4 of them in front of you. A note first, because the guide's own samples cover only 4 of its 6 scenarios, and developer productivity is one of the 2 with none. So this item is authored, not published. An agent explores a large monorepo across a long session using the built-in reading and searching tools. Late on, it answers from typical patterns instead of the classes it read, and the same question gets 2 different answers. The requirement is that a question about the refund flow must never be answered from a general pattern once the code's been read. Option 1. Move to a model with a longer context window so the whole exploration fits at once. Option 2. Add a line to the project instruction file telling it to stay consistent with what it established earlier. Option 3. Turn caching on over the exploration history so the earlier findings stay available cheaply. Option 4. Every phase writes its findings and their paths into a scratchpad, and it reads that scratchpad before answering. The verbose file reading gets pushed down into subagents too. Name the question first. It's about what the system still knows late in a long run, so it's asking what survives. Then find the absolute. The stem says must never, so the line in the instruction file dies where it stands. Guidance can't promise you anything about hour 2. The longer window goes next, because accuracy and recall degrade as the window fills, so it buys a longer runway to the same failure. Caching goes on the fact you just memorized, because a cached prefix still occupies the window. Option 4 is the only one where the finding leaves the context and can be read back afterwards. If it has to survive, it can't live in the history, and that's the answer. Look at where the system stands tonight, reviewing a large repository without losing what it established early on. The facts it has to keep no longer live in the part that gets summarized, and the verbose reading happens inside subagents. Findings land in a scratchpad with the paths they came from, and the conversation gets compacted on purpose. You can name which of the 3 mechanisms a problem needs and say why the other 2 wouldn't have fixed it. One line to walk into the exam with: if it has to survive, it can't live in the history. Then Nadia opens the exam guide. finds the situations the whole exam is built from printed inside it, and nobody has read them. Marco's at his desk with a timer running, and the first thing on the screen isn't a question. It's a paragraph about a production system, an agent wired into a backend through 4 tools with a target it has to hit. He reads it twice, and a chunk of his clock is gone before that screen has asked him anything. Then Nadia opens the exam guide beside him, and that same paragraph sits on her page word for word. Freeze it right there, because that paragraph isn't scene setting, it's the exam handing you the situation in advance. So, which of the printed situations are agent builds, which aren't, and what does each one mostly test? This episode owns no domain of its own because it's the frame that sits around all 5 of them. The guide publishes the situations this exam is built on, and it prints 6 of them in full. On the day, 4 are presented, picked at random out of those 6. So you're not answering 60 unrelated questions, you're working 4 situations with questions hanging off each one. By the end of this, you'll know all 6 by shape, which domains each one pulls from, and which architect question it tends to ask. And here is the line to carry through the whole episode. The situation is printed in advance, and it names who the answer is for. Marco read his Colt under a clock, and Nadia had read all 6 weeks earlier at her desk. Take that gap seriously, because it's the whole reason this episode exists. Reading a production context cold under a clock, with nothing you're allowed to look up, is the most expensive work you can do in that room. Doing the same reading at your desk, with no clock and nothing at stake, costs you close to nothing. One caveat said once, 6 is what the current guide prints, and its own cover says that list can change without notice. The other thing to get straight is what you sign, because before the exam starts, you accept that the questions and their options are confidential. So the sample questions printed in the guide are the only real items anyone can legitimately show you. Every other question in this course, including the one at the end of this episode, I wrote. So 6 printed situations, and the most useful thing about them isn't inside any one of them. Here is the split I didn't see until all 6 were laid out side by side. 3 of the 6 open with the same phrase, that you are building this thing with the agent SDK. Those are the support agent, the research system, and the developer productivity tooling. The other 3 aren't builds in that sense. 2 of them drop Claude code into somebody's repository. And the last one is a document pipeline with no agent and no repository anywhere in it. That leaves 3 and 3 across the line. So hold that split against the draw. You take 4 out of 6, so no draw of 4 can come entirely from one side of that line. Every candidate gets at least one agent build and at least one situation that isn't one. So you can't prepare for only half of this, and half is what most people prepare for. Start on the build side, because those 3 have more in common than their names suggest. First, on that side, the customer support resolution agent, handling returns, billing disputes, and account issues. It reaches your backend through 4 named tools: 1 to identify the customer, 1 to look up an order, 1 to refund, 1 to escalate to a human. The target is closing most cases on first contact while still knowing when to hand one over. The guide names orchestration, tool design, and context and reliability for it, and the question it asks most is what can it touch. Second, the multi-agent research system, where a coordinator delegates to specialists that search, analyze documents, synthesize, and write the report. Its output has to be comprehensive and cited, and those 2 words mean coverage and provenance. Same 3 primary domains as the support agent, but its question is where does the work run, because the failures here are about who got told to do what. Third, developer productivity, where the agent explores code nobody on the team wrote and takes the repetitive jobs off people. It uses the tools that ship in the box: reading, writing, running commands, and searching, plus MCP servers for everything outside. 2 of its 3 primary domains are the pair that make up what can it touch, so that's the question it asks. One rider on that one. It's one of 2 situations the guide prints no samples for, and the context episode works it with an item I wrote. That's the build side. Cross the line, and these stop being agents you designed. Over here, two situations put Claude code into a working repository. The first one is code generation, and it's the plainest of the six, where a team writes code, refactors, debugs, and documents. The work is fitting it to how that team already operates, their own commands, their own instruction files, and a call on whether to plan first. Its primary domains are configuration and reliability, and its question is what can it touch. The second one is continuous integration, and that's the situation this whole course has been building inside. Claude code runs in the pipeline, reviews the change, writes test cases, and leaves feedback on the pull request. The guide's emphasis there is on the prompt on feedback a person can act on, and on not crying wolf. So you'd expect its questions to be about how intent is carried, and this is where the guide surprised me. Every one of its published samples asks where the work runs, and not one of them is about wording. One's a job hanging with nobody there to answer it. One's which processing path a job belongs on. One's splitting a single pass into several. So a situation's stated emphasis is a starting bed about which question it asks, and it isn't a rule. That leaves structured data extraction, the one with no agent and no repository in it. Documents go in, fields come out, a schema decides whether the output is acceptable, and something downstream consumes it. Its question is how is intent carried, and the two words to hold from its description are edge cases and downstream. It's the other situation with no published samples, and the schemas episode works it with an item I wrote. That's all six. Now stack their domain lines on top of each other, because the tally says something, the weights don't. The guide names primary domains under every situation, so count how often each domain shows up. The smallest domain by weight, context management, and reliability is named in 4 of the 6, more than any other. 4 of 6 and you draw 4, so at least 2 of your situations name it and no draw avoids it. Prompt engineering is named in only 2. Both of those could sit out, and it's still about 12 of your 60 code items. That's the map. Now sit one item, because a map only pays off when a situation changes your answer. Time to sit one, and I wrote this one because it makes a point the published samples don't. The reviewer's output is inconsistent between runs. Sometimes a paragraph, sometimes bullets, sometimes a table. Whatever's on the other side can't rely on what arrives, and I've left the stem deliberately unfinished. 1. Add explicit criteria to the prompt with 2 worked examples of an acceptable verdict. 2. Emit the verdict through a tool call whose schema names every field and reject anything the schema refuses. 3. Move the review to the most capable model tier so the output settles down. 4. Add a paragraph to the project instruction file describing the required format. 2 of those die immediately. A capable tier writes better prose in whatever shape it feels like, so tier isn't a mechanism for shape. And the instruction file is guidance, so asking again in a second file can't fix a shape that already survived being asked once. Which leaves 2, and now the situation decides. Watch what happens when I finish the stem 2 different ways. First finish. The thing on the other side is an engineer reading the comment, who says half the findings are too vague to act on. A schema would hand that engineer a well-formed verdict that's still too vague to act on. So option 1 takes it, criteria and worked examples, because the failure is about content and the reader is a person. Second finish, same 4 options, nothing else touched. Now the reader is a service that rejects what it can't parse. The shape is the requirement itself now, so criteria make the right shape likely and a schema makes it certain. Option 2 takes it and not one word of the options changed. Only the consumer named in the situation changed, and there's the line again. The situation is printed in advance and it names who the answer is for. Real items don't arrive twice like that. I split it so you could watch the clause that moved the answer. Look at where that leaves Marco. This episode changed nothing in the build, and what it changed is the weeks before his exam. 6 situations, printed, and every word of that reading can happen at his desk. 3 of them are agent builds and 3 aren't. So a draw of 4 always crosses that line. Context and reliability is named in 4 of 6, so the smallest domain is the one you can't dodge. And the situation is printed in advance and it names who the answer is for. The next one Marco gets wrong is an answer. Nadia would sign off on in a review, and 2 words in the stem had already ruled it out. Marco's got the exam guide open at the back where it prints sample questions with the answers. He reads the first one and has his answer in 10 seconds because he's built this exact thing at work. He doesn't reread the other 3, he rings the one he wants and reaches for the answer page. Freeze him there, 1 page short of finding out, because those 10 seconds of certainty are what this exam catches. Here is the question he just answered. A support agent has one tool that looks up a customer and one that looks up an order, and both descriptions are a single line. Users ask about an order, the agent keeps calling the customer tool, and the question asks for the most effective first step. Marco rank consolidate the 2 overlapping tools into one and it's marked wrong. That's a real answer from a real engineer. It survived a design review and nothing in it is false. 2 words up in the stem had already decided it because it asked for a first step and rebuilding the tools isn't one. His option answers a question nobody asked, and this exam is largely built out of those. So this episode's about the paper itself and it's the only one with no domain and no task statement to cover. Every other episode teaches what the exam tests and this one teaches how the items get built. By the end you'll read a stem for the clause that rules most options out before you judge a single option. And you'll know the 3 shapes a wrong option takes from the examiner's own written explanations. One line carries all of it, the stem picks the answer, not the options. So start where the item starts. First move, and it's the one that changes your score fastest. Read the last sentence of the stem before anything else. On every sample the guide publishes, the ask sits in that final sentence, and it's never just good practice here. The most maintainable way, the most likely root cause, the most effective first step. Those are different questions, and the same system hands you a different right answer for each. You are not asked what's right, you are asked what's right for the thing that last sentence named. Second move, Marco's item says both tool descriptions are one short line and that isn't scene setting. The examiners say descriptions are the main thing the model uses to pick a tool, so the stem wrote the cause down for you. These items hand you the diagnosis mid-prose, and any option fixing some other weakness is a wrong option. You've got the requirement and the cause, so the last thing to find is what the stem won't allow at all. Third move, and this one does the killing. Find the clause that limits what can count as an answer at all. Sometimes that's the absolute from the first episode, the must or the never, and every option offering advice dies on it. A stem that says conventions must apply automatically has ruled out anything a person has to invoke, and the examiners kill an option on that. Often it's quieter though, and a stem about refunds landing in the wrong account rules out anything that only asks the model nicely. There is no absolute in that stem, so the consequence was the absolute, because money moving wrongly is a claim about every future case. So widen the rule. An absolute is any requirement that has to hold in the cases nobody's thought of yet. That's the reading half done, and now for the half Marco skipped. Now turn the item over and look at the wrong options, because they are built, not scattered. Marco's item carries all 3 shapes at once, and the examiners name 2 of them out loud. The first shape is plausible advice, and it's the dangerous one because it's nearly always a real technique. Few short examples, a firmer line in the system prompt, better docs for the rule, everyone keeps breaking. On Marco's item, the explanation says the few short option adds token overhead without fixing the underlying issue. Nobody's calling few shot bad there. They're calling it beside the point because the stem named a different cause. The second shape is the right answer to a question you weren't asked and it catches experienced people. The explanation calls merging the two tools a valid architectural choice, then rules it out anyway because the stem asked for a first step. That's Marcos 10 seconds. Good engineering does not win this exam. Answering the question that was asked does. The third shape is more machinery than the cause needs, like a routing classifier in front of the tools or a model trained on old tickets. The explanations call that over-engineered, and one says it wants labeled data and infrastructure before prompting stride. And one item kills buying your way out with a bigger model, because a larger context window doesn't fix an attention quality problem. So all three shapes test proportion, whether the fix reaches the cause the stem named at the size it asked for. Small isn't automatically right, so cheap wins when the stem asks for a first step, and mechanism wins when the stem says never, which is the same line again. The stem picks the answer, not the options. So take the three shapes back to the item Marco rang. Same item, same four options, but this time you read it in order. A support agent has two tools, one for customers and one for orders, and both descriptions are one short line. Users ask about an order, the agent calls the customer tool, and the last sentence asks for the most effective first step. Requirement first, and it's a first step, so effort counts here, not only correctness. Cause second, and it's mid-stem, two tools that look identical to the model. Architect question, and this one's about which tool gets picked, so it's what can it touch. Now kill by shape, add few short examples routing order questions to the order tool. That's plausible advice, aimed past the cause, gone. Build a routing layer that parses the user's words and pre-selects the tool machinery doing the model's job, gone. Consolidate both tools into one good architecture and the wrong question because it isn't a first step, gone. What's left is expanding each description so it says what formats it takes, what it's for, and where it stops. Three defensible options died there, and not one died for being bad engineering. That's the method on one item, and the item tells you one more thing before you leave it. The item tells you how many responses it wants, and that count is part of the requirement. Not everything here is single answer. Some items are multiple response, and each says how many to select. An item asking for two responses is asking two questions, not one question twice. Worth stressing because an earlier version of this exam's own guide said every item had one right response and three distractors. The published samples won't rescue you because every one of them is single answer, so they undershow the format. So read the instruction line before the options, and when an item wants two, check the pair isn't one idea in two hats. That's one item handled, and items here don't arrive one at a time. Each scenario sets up one production system and a whole set of items hangs off that single setup. In the guide's own samples, that's three items hanging off each scenario. So read the scenario once and build a picture first, what tools it has, what it must hit, and where a human sits. Then the items walk down the layers of that one picture, and each layer is a different architect question. Here's the trap. Few short examples are a wrong option on two of the support agent's items and correct on the third. Nothing carries between items, so an option you killed a minute ago can be the answer now because the requirement moved and the system didn't. That's how the paper works, and two things narrow it before you sit down. The current guide publishes a list of topics it says will not appear on the exam. Fine-tuning or training custom models, hosting and deploying MCP servers with the networking that implies vector database internals, computer use, image analysis, streaming, token counting, and cloud provider configuration. Rate that list as a filter because an option resting on what the guide leaves out is rarely the one they want. Say it as what the current guide excludes though, never as a promise, because the cover says it can change without notice. The second narrowing is the room closed book, desk clear. one screen, no AI helping you. So you carry a method and not a pile of facts. One thing that has nothing to do with the questions and still ends sittings, your photo identification has to match your registration, and sign up still runs through Anthropic's partner network. So it wants a company email on a partner domain, not a personal one. So here is the method in the order you use it. Read the last sentence first, find the cause the stem handed you, then rule out what the stem won't allow at all. Kill by shape instead of arguing option by option, and count the responses the item asked for before you leave it. What comes back is a scaled score against a fixed standard, not a curve against other candidates. The report also breaks you down by domain, and that part's diagnostic only, but it names which architect question you are weak on. Marco read his item again, last sentence first, and the option he rang lost to a two-line description change. The stem picks the answer, not the options. And come back because the reviewer just contradicted itself on 14 files. Nadia opens the review her system just posted on a pull request that touches 14 files, and the report contradicts itself. The same pattern shows up in two of those files, flagged as a problem in one and signed off without a word in the other. 3 files got careful, specific feedback, and the 11 behind them got one vague sentence each. Nothing failed here. There is no error, no timeout, no crash, and every specialist reported success. The work was never too hard for it. The work got handed over in the wrong shape, all 14 files at once. Freeze right there, because the exam is built out of moments exactly like this one. 14 files handed over in one pass, and the depth came back uneven across all of them. So what was wrong with the handover? Nadia's reviewer already has a coordinator and 3 specialists, and this is where that coordinator stops being enough. Agentic architecture and orchestration is the biggest domain on the exam, roughly 16 of the 60 questions you'll see. This episode owns the decomposition objective, and it owns multi-pass review, which the guide files under prompt engineering. By the end, you'll look at a job too big for one pass and see where the cut goes, and whether it needs more passes or more workers. The architect question parked in the corner, all episode is the first of the 4. Where does the work run? Start with why one pass came back uneven, because the reason picks the fix. We are at the diagnosis, and the guide already has a name for what went wrong. Attention dilution is what happens when one pass holds many things at the same depth, and it arrives with contradictory findings. Picture a fixed handful of attention spread over 14 files, so each one gets a sliver, and a sliver reads shallow. This isn't the context problem from earlier in the course, where the system lost what it had established at the start. Nothing got lost here. Every file just got a thinner share of the care. The fix most people reach for is a roomier pass, and more room gives the work space to sit in rather than more care. So here is the line to carry. When the depth comes back uneven, the cut is wrong, not the model. If one pass can't hold 14 files, what shape do you hand it instead? That shape is the fix, and the guide names it precisely. One local pass per file, and then a separate pass that only looks across the files. The per file pass has one job: read this file, judge this file at full depth with nothing else competing for room. Then comes the pass people leave out of their answer, and it looks at data flow between the files and the calls that cross a boundary. That's where a value handed from one file to another goes wrong, and no per file pass can see it. So the principle is one job per pass. Depth inside a file and connections between files are 2 different jobs. The same objective names a third pass, where the model reports a confidence level beside each finding so routing can use it. Passes fix depth, but a split can still be a bad split. So the next thing to get right is where you put the knife. Here is the rule that decides whether a cut is any good. Cut the work so the pieces don't need to talk to each other. If piece 4 has to stop and ask piece 9 what it concluded, your parallel design is a queue with extra steps. A per file pass needs one file and nothing else, and that's exactly why all 14 can run at once. The exam names two shapes of decomposition, and the first is a fixed sequential pipeline, also called prompt chaining. Per file, then integration, then the summary, in that order every time, and you pick it when the work has predictable aspects. Nadia's review is exactly that because she knows the steps before the pull request even arrives. The second shape is dynamic decomposition, where the plan gets generated out of what the earlier steps actually found. Add comprehensive tests to a legacy code base is that kind of job because nobody can list the subtasks in advance. So the guide maps the structure first, marks the high impact areas, and lets the plan change as dependencies turn up. That's the cut. And there's a second failure underneath it, because a pass can review what it wrote itself. The cut is right, and the passes are deep, so here is the failure that survives both of them. Nadia's system writes a fix, and then the same session reviews the fix it just wrote. The guide is specific about why that goes badly, because it's still holding the reasoning that produced the thing. And the guide goes further, telling it to review its own work carefully doesn't fix this, and neither does thinking for longer. What fixes it is an independent instance that never saw the reasoning and only ever sees the result. Say it as a rule. A review by the thing that wrote it isn't an independent review, however firmly you ask. That's one more worker. And once you are adding workers, the middle starts to strain. Every message in our own system goes through the middle. So with a dozen workers, the middle becomes the bottleneck. There is a documented shape for that called an agent team where one session leads and the others are teammates. Each teammate has its own context window. They share a task list and they message each other directly. So the lead synthesizes results instead of relaying them one exchange at a time. Say it plainly. Subagents when only the final result matters, a team when the workers need to argue with each other. Those messages reach sessions on the same machine or on another one, and they're deliberately weak. A message from another agent can't approve a permission prompt or change configuration, so treat it as input, never as authority. Teams are experimental and off by default, so check the build in front of you rather than trusting a video. And peers all writing to one repository at once brings a blunter problem. The workers can talk to each other now, and the next thing to settle is what happens when they all write. Several workers editing one repository at the same time will write over each other, and nothing warns you. So each one gets its own working directory. A work tree has its own files and its own branch, sharing the repository history, and the remote edits in one work tree never touch another's files. A write reaching into the main checkout gets blocked, and you set it per worker or session. When a stem says two agents must never overwrite each other's work, a blocked write is a mechanism and an instruction isn't. Each worker also carries its own dials per worker rather than global effort, a turn cap, the model tier, the tool allow list. That's the whole tier. So here is the item that proves you needed it. The guide publishes a sample question and it describes Nadia's system symptom for symptom. A pull request modifies 14 files across one module, and the single pass review produces inconsistent results. Detailed feedback for some files, superficial comments for others, obvious bugs missed, and a pattern flagged in one file but approved in another. That's her report almost word for word. How should you restructure the review? Option A. Split into focused passes, each file analyzed on its own for local issues, then a separate pass on cross-file data flow. Option B. Require developers to split large requests into smaller submissions before the automated review runs at all. Option C. Move to a higher tier model with more room, so all 14 files get adequate attention in one pass. Option D. Run 3 independent passes over the whole request and only flag issues that turn up in at least 2 of the 3. Name the question first. Every option is a proposal about how the work is arranged, so this is where does the work run. There is no must and no never in that stem, so the elimination rule stays holstered and the symptoms have to name the root cause. C dies first because a roomier pass gives the work more space to sit in rather than more care. When the depth comes back uneven, the cut is wrong, not the model. B isn't an architecture answer at all. It hands the problem back to the developers and leaves the review as broken as it was. D is worse than doing nothing, because requiring 2 of 3 runs to agree suppresses exactly the bug that only gets caught intermittently. A is the answer, per file passes for local depth, and 1 integration pass for what happens between the files, which is the cut we'd already made. So the exam isn't checking whether you memorized the pattern, it's checking whether you'd have made the cut. One more from the same set. A research system gets the impact of AI on creative industries split into digital art, graphic design, and photography. Every subagent succeeds at its task, and the final reports cover only visual arts with music and writing and film missing. 3 of the 4 options blame a downstream agent, and all 3 are wrong because those agents did their work correctly. The decomposition was too narrow, and no worker can cover ground it was never handed. Look at where Nadia's reviewer stands tonight. 14 per file passes for depth, 1 integration pass for what runs between them, and an independent instance reviewing what it wrote. The workers sit as peers with a shared task list, each in its own worktree, and the coordinator isn't the bottleneck anymore. 2 lines to walk into the exam with. When the depth comes back uneven, the cut is wrong, not the model. And a review by the thing that wrote it isn't an independent review, however firmly you ask. Next time it has to survive being interrupted because everything we just built is worth nothing if a restart loses all of it. The reviewer is deep inside a big pull request with 4 passes running at once, and it's fast. Then the pass reading the test suite stops answering. The coordinator sits there waiting on something that isn't coming back. So the run gets killed and started again because that's the only move anyone has. The new run starts from nothing. It rereads every file, re-derives every finding, and asks the tracker the same questions again. Everything the dead run worked out is gone, and none of it was written anywhere a restart could reach. Freeze right there, because that restart is exactly what this exam turns into a question. Nadia asks the only question that matters. What happens when this dies on the 2 in the morning merge? So what should have been waiting for that restart, and what should the dead pass have said on its way out? That question comes from the smallest domain on the exam, context management and reliability, roughly 9 of the 60 questions you'll sit. It also takes the last task statement in the biggest domain, the one on session state, resumption and forking. That's 4 task statements, and they all answer the 4th architect question parked in the corner. What survives? By the end you'll know when to resume and when to start clean, what a failing pass sends up, when to hand off, and how a claim keeps its source. Start with the restart, because nothing else matters if it can't come back. What should have been waiting for that new run isn't exotic. It's a notebook. Anthropic documents a pattern for exactly this, and it's deliberately boring. It starts with a session that does no real work. That session writes a progress log and a checklist, and every session after it reads both and updates them before it ends. Their own line for it is that this turns memory into a recovery mechanism. Say it as a rule you can use. If a restart can't read it, it didn't survive. Claude code carries the other half because a session can hold a name and you can resume that one. A resumed session brings its old tool results with it, and a tool result is a photograph of one moment. If the code moved while it was away, those photographs are stale and the model still reads them as current. So resume when the old context is mostly true and start fresh with a summary when the results have gone stale. And when you resume, name the files that change, which buys a targeted reread instead of a full re-exploration. One more move in the task statement, because a session can also be forked. The expensive part is the understanding, so you pay once and branch, comparing two testing strategies without paying twice. So the reviewer can come back. What did that dead pass over the coordinator on its way out? The restart has a notebook now, and the next job is the failure itself, where three ways to get it wrong all read as careful engineering. The first one swallows it. The subagent catches its own timeout and returns an empty result marked successful. Now, a failure looks exactly like a search that found nothing, and the report ships with a hole and no sign of one. The second one reports it generically. The subagent retries, runs out of retries, and sends up a status that says search unavailable. That's honest and useless because the coordinator can't tell what was tried, so it can't pick what's next. The third one sends the exception to a top level handler that shuts the whole rundown. That's the cold open. One dead pass costs three finished ones. All three take away the same thing, and it's the coordinator's ability to decide. So here is the line to carry out of this episode. A failure has to arrive with a decision still attached. What the coordinator needs has a name, structured error context, and the guide lists four fields. Failure type, what was attempted, partial results, and the alternatives worth trying. With those four, it can retry narrower route around the dead pass, or finish with partial coverage and say so. Replay the cold open with that card arriving. Nadia's run doesn't die, it comes back three passes deep with the gap named. One exam favorite hides here because an access failure and a genuine empty result aren't the same event. A timeout means try something else. Zero matches means the answer is zero. And the division of labor is explicit because a subagent fixes the transient failures it can and sends up only what it couldn't. So a failure travels now. Next is the case where nothing failed and the system still shouldn't answer. The system can report a failure now, and next it needs a way to stop when nothing has failed. Escalation has three named triggers, and difficulty isn't one of them. Someone explicitly asks for a human. That's one. The policy is silent or ambiguous about what's being asked. That's two. And the system can't make meaningful progress. That's three. Two proxies get called out as unreliable, the tone of the request and the model's own confidence, because neither measures complexity. When someone asks for a human, you hand off straight away without investigating first to prove you could have handled it. When the tone is bad but the fix is inside what the system can do, acknowledge it and escalate only if they ask again. The trigger people design out by accident is ambiguity, like a policy covering your own price adjustments but not a competitor's. The system doesn't have an answer there, it has a gap, and guessing into a gap turns into a precedent nobody agreed to. Same shape when a lookup returns three near identical rows because the system asks for one more identifier instead of guessing. And the fix isn't code, it's escalation criteria in the system prompt with worked examples of escalate against resolve. Stopping is covered. Now the opposite reflex, trying again, which does damage that's easy to miss. Retries are the next job in the build, and most of that work is already done for you. The official client libraries already retry transient failures for you with backoff, and they honor a retry after hint when one comes back. So the retrying is handled. That's not the part that hurts you. The connection drops just after the reviewer posted its comment on Marco's pull request. The retry lands, and now there are two. A retry is only safe if the thing being retried can happen twice without doing damage twice. That property is not in the library, you build it. So make the effect idempotent, which means your code generates an ID and keys the side effect by that ID. Posting a comment becomes lookup. The comment for this ID, write it. If it's missing, replace it if it's there. And don't retry what can't succeed, because a malformed request will be malformed the second time too. One more trap, because on a streamed response, the error can arrive after the success status. So success isn't a successful turn. One piece left, and it decides whether the report is worth anything. Watch what happens to a finding on its way into the report. Attribution dies at the summarization step. because compressing a finding drops the mapping from a claim to what said it. The four passes summarize, the coordinator merges them, and the report tells Nadia the migration is unsafe with nothing behind it. So require the mapping as part of the output, where every claim carries the file it came from and the excerpt that backs it. Then synthesis merges those mappings instead of rewriting everything into prose that drops them again. Then conflicts, where the instinct is to pick the more credible source. That's your distractor. Both values go up annotated with their sources, and the coordinator reconciles them. A lot of apparent contradictions are only two different moments, so the output has to carry the publication or collection date. And the pass that timed out earns a line as a coverage gap in a report that separates what's well supported from what's contested. That's the build. Now sit the guide's own published question on it. In the multi-agent research scenario, a search subagent times out, and you design how that failure gets back to the coordinator. Option 1. Catch the timeout inside the subagent and return an empty result set marked successful. Option 2. Retry inside the subagent with backoff and return a search unavailable status once the retries are gone. Option 3. Send the timeout to a top-level handler that terminates the whole research workflow. Option 4. Return structured error context, the failure type, the attempted query, any partial results, and the alternatives. Every option here is about what the coordinator gets told, so it's a what survives question. One dies first because it files a failure as a success and nothing downstream can recover from what it can't see. 3 dies next because one timed out search doesn't justify destroying work the others finished. 2 catches careful people because retrying locally is genuinely correct. It dies on its second half, where the retries run out and it sends up 2 words with no decision in them. 4 is the answer, the only option that leaves a decision available to something that can still act. That's the test for every error handling item on this exam. A failure has to arrive with the decision still attached. Look at where Nadia's reviewer stands tonight. It can be killed and come back to a recorded state instead of a blank board. A failing pass sends up what it was doing and what it got, so one timeout costs 1 pass and not the run. It stops when the rules are silent, its side effects survive a retry, and every claim still knows its source. 2 lines to walk into the exam with. A failure has to arrive with a decision still attached. And if a restart can't read it, it didn't survive. Next time the reviewer posts 3 findings on a big pull request, then stops half done, 1 run in 10. The reviewer posts 3 findings on a 12 file pull request, then stops and the review sits half done. It does that about 1 run in 10, and the loop it runs today ends when the model's reply contains the word done. Freeze it right there, because a loop that stops on a word is the kind of moment this exam turns into a question. Here is that stall the way the exam writes it. So what should end that loop instead? Option 1. Raise the iteration cap so the loop gets more rounds. Option 2. Tell it in the prompt to write done only when the review is genuinely complete. Option 3. End the loop on the response's stop reason, continuing while that reason is a tool call. Option 4. Have a second instance judge whether the review looks finished before it's posted. Most hands go straight to the 4th one. Reaching for the biggest machine on the page is the most expensive habit on this exam, and it's the one this episode takes off you. So the rest of this is a lab, 7 questions across all 5 domains, weighted like the exam. 2 of the 7 sit on the largest domain. Roughly 16 of the 60 questions you'll sit, 1 on each of the rest. The last one's a multiple response item that tells you how many to pick, and almost no preparation drills that all 7 were written for this course, because the real ones sit behind a confidentiality agreement. 2 people can know this material equally well, and one gets 5 of these 7, the other all 7. The difference isn't memory, it's 3 reads run on the stem in a fixed order, and you already own the first 2. So let's run them on the item you just heard, and watch where they stop. First read, name which of the four questions you are being asked. This one's about how the loop decides it's finished, so it's a where does the work run. Second read, look for the absolute, and there is no must and no never anywhere in that stem. That's where most people stall. When there's no absolute, the stem has already named the cause. The loop ends when the reply text contains a word, so control flows decided by reading prose, and there's the cause. A bigger cap leaves the prose reading intact, and the guide names an arbitrary cap as an anti-pattern itself. Wording the word more carefully is advice bolted onto the same broken exit. A second instance is a whole extra reviewer for a bug that shows up one run in 10. The stop reason is the field the loop's meant to branch on, so continue while it's a tool call, stop when the turn ends. Option 3 is the answer, the smallest change on the page that removes the cause. So say the third read as a rule. No absolute answer the cause the stem named at the size the evidence justifies. The next item hands you an absolute, and one word does more work than you'd believe. Item 2, same system, and this is the shape you'll meet more often than any other. A change touching the migrations directory must never reach a green merge gate before the schema specialist has returned its verdict. Option 1 say in the system prompt that schema review comes first. Option 2 add examples showing schema review before the gate. Option 3 put the ordering rule in the file committed to the repo. Option 4 a hook on the gate tool call that blocks it until a verdict exists. Option 5 give the coordinator a checklist skill it runs at the start. First read what's the system allowed to do to the gate, so it's a what can it touch. Second read finds must never, and now watch what one word does to a 5 option item. The system prompt, the examples, the committed file and the checklist skill are 4 ways of telling it. Prompt instructions on their own have a failure rate that isn't 0 and the requirements said never. So 4 of the 5 die together on one word before you've read them properly. The hook's the only thing on the page sitting in the path of the call, so option 4's the answer. An absolute doesn't knock out one distractor, it sorts the page into telling and blocking, and telling loses. Back to the common case, the next item has no absolute and 2 things going wrong at once. Item 3 domain 2, and the reviewer reaches a tracker and a coverage service through MCP servers. Both return the same string on every failure, so a brief outage and a query that matched nothing look identical. 4 options: retry with backoff, structured error responses, better tool descriptions, or escalate every failure to a human. No absolute, so third read, and this stem names 2 symptoms instead of 1. Blanket retries fix the outage half and make the empty half worse, and an option that repairs half a stem is a distractor. Better descriptions fix picking the wrong tool, which isn't what broke, and escalating everything hands a short outage to a person. So option 2 is the answer, a category, a retriable flag, a readable description, and an empty result reported as a success. Next item, the cause is hiding in one clause. Item 4, domain 3, where Nadia's machine applies the org's review conventions and a new hires doesn't. Same repo, same commit, and on Nadia's machine, those conventions live in the instruction file in her home directory. 4 options: commit them at the repo root, copy them into everyone's home file, put them in a skill, or add them to the pull request template. No absolute, so third read, and there's the clause that hands you the cause. A file in a home directory isn't shared through version control, which is the whole reason the new hires run differs. Copying it around the team breaks with the next hire, and a skill loads on invocation when these must load every run. The template's a note for humans, the reviewer never reads, so option 1's the answer, the committed repo file. Next one puts an absolute back in and it doesn't want a hook. Item 5, domain 4, and the merge gates an automated job that reads the reviewer's verdict. It must never receive a verdict it can't parse, and the reviewer keeps wrapping its JSON in a sentence of explanation. 4 options. Tell it to output only JSON. show 3 formatted examples, define the verdict as a tool with a schema, or retry on a parse failure. First read, does intent arrive intact? And the second read finds must never. So the prompt line and the examples die. Retries closer because it's a real mechanism and it still narrows the window instead of closing it. The schema on a tool is the only option where a malformed verdict isn't a possible outcome. So option 3 is the answer. And a strict schema kills syntax errors and does nothing at all about semantic ones. Next, two sources disagree and nobody says so. Item 6, domain 5, where two sources disagree about the coverage threshold a module needs. The design doc says one number, the live report says another, and the summary picked one without saying which. 4 options. Prefer the live service, return both values annotated with source and date. Note that sources sometimes disagree or drop the threshold. No absolute. So third read, and the cause is that a step which wasn't allowed to decide went ahead and decided. Preferring the live figure is the arbitrary selection the guide warns about, and the stale doc stays stale. A general note maps no claim to any source, and dropping the field removes the one thing Nadia asked for. Option 2 is the answer, and the date on each value isn't decoration, because two figures from different times often aren't a contradiction. One left, and it changes how you work it before you've read an option. Item 7, and a strip across the top changes how you work it because it says select 2. Every specialist holds every tool the system has, including the gate tool and a deploy tool. Tool selections gone unreliable across the board, and the style specialist has called the gate twice. 5 options. Scope each tool list to the role, tell the style specialist never to call the gate, merge the tracker and coverage tools. Then keep the gate on the coordinator alone, or raise reasoning effort on every specialist. Read the count first, because you are looking for 2 changes. 2 and you stop, and if you've got 3, you misread one of them. Option 2 has the word never sitting in it, and that's the trap. An absolute inside an option isn't an absolute in the requirement, so it dies as ordinary advice. Merging two tools rebuilds the ambiguous description problem, and more reasoning effort doesn't take a tool out of the box. Options 1 and 4 are the answers, because too many tools widens the decision and a tool outside a role is there to be misused. That's 7, so score them by domain before the close. 3 reads in the order you run them. Name which of the 4 questions you are being asked, and half the options go off the point. Look for an absolute, and when there's one, let it kill every option. That's only a way of telling the system. And when there's no absolute, which is most of the time, the stem has already named the cause. So answer that at the size the evidence justifies. So that answers what we opened with. The one who gets 7 isn't remembering more. They're reading the stem as evidence, not scenery. Score yourself by domain rather than by total, because a miss tells you which episode to go back to. Nadia points out this whole thing started with one engineer pasting a diff, and nobody's ever walked the finished build as one system. The whole system started here, with one engineer pasting a diff into a prompt at the end of the day. It worked until 2 more pull requests landed while she was still on the first one. The billing change is third in that queue, and it merges without anybody looking at it. Nothing notices, and that's the honest part, because there's nothing in there that could notice. Freeze right there on a merge nobody read, because that gap is what this whole exam is about. So here is the stem, exam style. What's missing from that setup, and which domain owns each missing piece? That's the last question in this course, and it takes one walk through the finished system to answer. 5 domains, 30 task statements, 60 questions, and 1 system instead of 5 lists to memorize. So hold this line for the whole walk. 5 domains on paper, 1 system in the room. At every stop, I'll name the decision, the question it answered, and the domain, starting with the smallest thing she built. Stop 1. 1 loop, 1 pull request, and it was genuinely enough. Send the request, read the field that says why it stopped, run the tool it asked for, append the result, go round again. Then 40 files land in one pull request, and the loop that was excellent yesterday goes shallow. It didn't run out of information, it ran out of attention. So stop 2 splits it. A coordinator in the middle with 3 specialists around it, every message routed through the middle. And a specialist wakes up on an empty desk, holding nothing but the string you handed it. Nothing crosses on its own, so whatever the coordinator knows has to be typed into that prompt. Both stops answer where does the work run, and domain 1 is the biggest, roughly 16 of the 60 you'll sit. The team can read the code now and it still can't make anybody listen to it. Stop 3 is the one this course leans on. Everything so far produces a comment, and a comment is advice. The guide says it flatly. Where compliance has to be deterministic, an instruction carries a failure rate that isn't zero. A comment can be ignored, a mechanism can't. So 3 go in, and the guide scores each one separately. A hook that sits in the path of the call and stops it dead when the rule is broken. A handoff that carries the root cause and the recommended action to somebody who never saw the conversation. And a signature on anything that moves money, which makes a person unavoidable instead of invited. Hook and handoff are domain 1. The signature is domain 5 and a stem that says never wants this column. The reviewer can block a merge now and it still can't see past the diff. Stop 4 is about what it can reach, and today it reaches the diff and nothing else. So first, the tools that already ship, the ones that read a file, search the tree and run a command. Then the field that decides whether it picks the right one, the description written on the tool itself. Then the protocol for the systems your org doesn't own because the tracker lives over there. And the errors those tools hand back with a category and a retriable flag, so it knows try again from stop. Stop 5, same question, new surface. 3 teams run this thing 3 ways and it uses the wrong conventions. A project file everybody gets on clone, then a rule file bound to a path pattern since test files sit in every directory. Then a skill with its own tool restrictions running to the side so its mace stays out of the main conversation. Stop 6. Nobody's awake for the 2 in the morning merge. So a person is the single point of failure. So it stops needing one, a non-interactive run, then a pipeline stage with plan mode kept for changes that need designing. Domains 2 and 3 are both what can it touch, closer to 23 of your 60 than to 20. It reaches everything it needs now, and people have started ignoring what it says. Stop 7 is about how intent gets carried, and right now it flags everything. People close the tab, and the firmware instruction won't reopen it. The fix is criteria you could test, a list of what to report and a list to leave alone, plus examples for the hard calls. Stop 8. The verdict is good prose. The merge gate is a program, and a program can't read prose. So the output gets a shape instead of a style, with nullable fields for what genuinely might not be there. Then validation and a retry that sends the specific failure back with the work instead of asking again politely. And the overnight report moves to the batched route, while the blocking check a developer waits on stays live. Domain 4, about 12 of your 60, and the question here is how is intent carried? The reviewer says the right thing in the right shape now, and on a big repository it forgets the files it opened. Stop 9 is about what survives, and the first thing that doesn't is what it already read. Same reviewer, bigger repository, and it answers from typical patterns instead of the classes it actually opened. No error gets raised because it gets vaguer while sounding exactly as confident. So you decide upfront what can't be summarized and it sits outside the summary in full, tool output trimmed. And every finding carries the path it came from, so a claim can be checked. Stop 10. One box in the middle is also one queue in the middle, so the coordinator is the bottleneck. So the review splits across instances, each file alone for local problems, then one pass for what shows up between them. Preparation reaches for a bigger context window here, and a bigger window doesn't buy attention. Stop 11. Something dies halfway through a long review, and a restart throws away what it had learned. So the session gets a name and can be resumed, and you learn when resuming is worse than starting fresh. A failing part reports what it tried and what it had before it died, not a generic failure nobody can act on. And it escalates on the two things it isn't allowed to decide: a gap in the policy and a real dead end. Domain 5 around 9 of your 60, and it's the one candidates leave until the time runs out. So that's the system: 11 decisions, 30 objectives, 5 domains on paper, 1 system in the room. Which means the honest move now is to say what it still can't do. Here is the part a course usually skips, because a system with no stated limits is a sales pitch. Nothing here measures whether the review is correct, and one accuracy number hides whole categories of miss. It can't rank its own findings by how sure it is, because the confidence score it reports about itself isn't calibrated. Everything that manages context compresses something, so provenance only holds for what you kept out of the summary. And a retry can repeat an effect out in the world, so making a tool called safe to run twice is your code's job. None of that's a reason not to build it. It's the list you say when Nadia asks what it doesn't cover. And one exam item sits right on that edge. One question to finish, and it's the only one in this course that needs 2 of the 4 to answer. Take the build one stop short of finished. The gate must never report a clean review when part of it didn't run. On a big pull request, one pass times out, the coordinator finishes anyway, and the gate reads no blocking findings. Tell the coordinator in its instructions to mention any pass that didn't complete. B. Retry the whole review from the beginning whenever a pass fails. C. Have the failing pass return its failure type and partial results, and make the verdict carry a coverage field the gate checks. Run the review on the most capable tier so passes stop timing out. The stem says must never show A is gone for the same reason it was gone in the first episode. B treats a reporting fault as a flaky one, and a second timeout gives the gate the same clean verdict. D lowers a failure rate, and a failure rate is not never. C is the answer, and its halves live in different domains, the failure reporting in 5 and the coverage field in 4. The fault was in what survives. The mechanism is in how intent is carried, and you saw both because you walked them as one build. So here is what you carry into the room. Name which of the 4 the item's asking, then find the absolute and let it kill the advice. The coverage map is 30 task statements with an episode against every line and no blanks in it. Every number that can move lives in the course notes, and the cheat sheet corrected the day it moves. One honest thing about getting in: registration currently runs through Anthropic's partner network on a company email at a partner domain. A personal address is rejected, and joining at the entry tier is free, so it's an internal conversation, not a purchase. And the merge this episode opened on: the billing change nobody looked at can't get through this system. A pipeline stage runs the review whether anybody remembers or not, and the hook holds that merge while billing's in it. Then a signature lands on anything that moves money, so the last call belongs to a person instead of a hurry. Marco's team has nothing left to work around because the rule stopped being a sentence in a file, and Nadia has a guarantee instead of a promise to be careful. 5 domains on paper, 1 system in the room, and every item on this exam is now a mechanism you watched work.